So welcome, folks. Thanks for coming back for day two of our event. If anyone's here for the first day, then welcome. Thank you for joining us today at the first session in the Building Relationships That Support Wildlife track of the 29th Annual ELA Conference. My name is Dan Wilder. I sit on the ELA Board of Directors, and I will be your host for this session. If you're comfortable, we encourage you to please join us with your camera on. Frankly, it's just nice to see faces in this virtual environment. We're sure you will enjoy hearing from our first presenter, Brian Windmiller. I want to give a special thanks to our sponsors. Sponsorship is especially challenging in the virtual environment, and frankly, we can't hold this event without the sponsors. So I encourage all of you, whether you're interested in buying anything or not, just drop into on the sponsors, say hi, strike up a conversation. They're nice people, they got a lot to talk about, and it's well worth your time. So to them, special thanks to you. That's Pleasant Run Nursery, Understanding Ag, Soil Health Academy, TickSuit, and Ernst Seeds. A few quick housekeeping notes. Please post any of your questions in the chat. We're going to answer as many of them as we can at the end of the lecture. For any that we don't get to and for further discussion, join us in the Track 3 Speaker Garden. If you're looking for CEUs, there's a tab in the main space that frankly explains everything you're going to need for CEUs. If you have any questions, you can join the video in the main space, and we've got ELA staff waiting there to help you with any questions you might have. If you haven't yet filled out your profile in the Kiku platform, please do. We like seeing where everyone's listening from, and when we set up our networking lounges, we do it by region, so you can talk to folks that are local to you. If you need to edit your profile, go to the conference space in your browser, click on your name in the top right corner of the page, and click on Edit Profile. If you have any questions about using the space, you can post that in the chat as well. You can also chat directly with tech support on the bottom right corner of the conference main page. We also have a jobs posting board. If you have a job opening or if you're interested in jobs, go to the jobs board main tab in the main space and post what you've got. And thanks again for being here today. With that in mind, we're going to get started. So I'd like to introduce our first presenter. This is Brian Windmiller. Brian Windmiller is the Director of Field Conservation at Zoo New England, where he oversees the zoo's local wildlife conservation programs and its support of international conservation efforts. Brian earned a PhD in biology and a master's degree in environmental policy, both from Tufts University, and he's worked in various roles as a conservation biologist since 1987, specializing in the restoration of rare turtle, frog, and salamander species in Massachusetts. Brian is an adjunct professor at the Tufts University School of Veterinary Medicine, and he has taught at several Massachusetts universities. Please join me in welcoming Dr. Brian Windmiller.
Okay, well, hello, everyone. I'm going to start out by relating a little incident, part of the central metaphor in a book, Braiding Sweetgrass, that many of you have probably read by Robin Wall Kimmerer. In that book, Professor Kimmerer describes asking her undergraduate students to describe some ways in which human actions negatively impact species of wild animals and plants. Not surprisingly, her students write piles. They have no trouble thinking of lots and lots of such examples. Then Professor Kimmerer asks the same students to write about some ways in which human actions positively affect populations of wild animals and plants and their ecosystems. And most of the students can't think of any. That fact has more to do, as Ms. Kimmerer notes, and I agree fully, with our particular cultural biases than it does with ecological reality. Today, I'm going to touch on some of the ways that wild animals and plants take positive advantage of human-dominated environments, and that both they and humans reside within. And I'm going to describe some opportunities that landscapers and ecologists, people in small conservation nonprofits might have to construct or conduct small-scale projects that can benefit rare, declining, or struggling species of wild animals and plants in our environment. I'm going to start out from a global perspective. So as many of you know, the number of humans on Earth has recently officially ticked above 8 billion. As a just gross measure of the impact that we have on the world as a whole, there are about 5,400 species of mammals known on Earth. And if you just take all of us humans and all of the cows and pigs and other domestic mammals that we grow for food and weigh all of those together, their mass comprises about 96% of all mammal biomass, of the weight of all 5,400 species. Look at it another way, if you want to focus on birds, the weight of all of the chickens and turkeys that we raise for food is about triple the total biomass of all 10,000 species of wild birds in the world. And for literally tens of thousands of years, humans have been hunting and killing other wild animals at numbers sufficient to drive their populations down, and in many cases to extinction, and leaving others like this northern white rhino teetering on the edge of the abyss. Today, though, the greatest threat to the existence of many animal and plant species is no longer direct hunting and killing by humans, but rather habitat destruction and alteration in all of its myriad forms, which is when forests and prairies are cleared or wetlands are drained to make room for farms, pastures, and human settlements. Here in the United States, we lost our largest species of woodpecker, the ivory-billed woodpecker, largely as a result of widespread logging and fragmentation of the mature old-growth bottomland forests that once covered most of the coastal regions of the southeastern United States. Yet, the news is not all bad. In fact, many wild animal and plant species in many parts of the world are actually becoming more abundant. I live in the town of Concord, Massachusetts, and so share the same hometown with Henry David Thoreau. These 8 species shown here all share a connection with those facts. Henry didn't see any of these species during the years of his life in Concord, Massachusetts, when he chronicled extensively the natural history of the area in his journals from 1837 to 1861. All are now widespread in the town of Concord. All 8 of these species were certainly present and probably widespread in Concord 500 and more years ago, yet all were completely extirpated by the 19th century or by the late 19th century in Concord because of widespread forest and wetland clearing for agriculture and for settlements, and also by commercial trapping. When Henry was writing, only about 10% of the land area of Concord, Massachusetts was forested. Today, about half of Concord is forested, and all of these species are not only present, but generally thriving, and in Massachusetts and New England as a whole, generally increasing in abundance. Some of the species, like white-tailed deer and eastern chipmunks, are likely higher in number in total population in New England than they ever were before. As in the case of the recovery and recent increase in both the abundance and the distribution of species like fisher and bobcat, and pileated woodpecker in New England, many wildlife species rebound just fine from past anthropogenic decline when humans simply stop doing whatever it is that causes their decline, whether that's hunting and trapping or destroying and degrading their critical habitat. The Cuyahoga River that flows through Cleveland on its way to Lake Erie infamously caught on fire 14 times from the late 19th century until the last fire in 1969. And it was the last very well publicized 1969 fire that helped spur a lot of the environmental movement that eventually resulted in the passage in 1972 of the Clean Water Act. And 5 decades hence, through lots and lots of work, the Cuyahoga is much cleaner, and native fish have returned and increased in diversity as a result. In 1969, when the river last burned, the EPA sampled the whole river through Cleveland and could only find 10 individuals of one species of fish, gizzard shad, all of which were noted as looking sick. Today, recently in 2008, in a resampling, EPA found thousands of individuals of 40 different fish species, several of which are quite sensitive to pollution. And today, the Cuyahoga watershed has recovered to the extent that there's an active reintroduction project for lake sturgeons, like the guy on the right, endangered species in Ohio. And so people didn't abandon their farms and pastures in New England and let it regrow into forest because they wanted to benefit fishers. And the people in Ohio didn't stop polluting the heck out of the Cuyahoga River simply because they liked sturgeon and other fish. Humans can therefore unintentionally benefit wildlife by acts of omission. That is, when they simply stop doing whatever it is that is injurious to those species. But humans can also, by their actions, by acts of commission, create circumstances that greatly benefit populations of some wild plant and animal species. In New England today, as most of us know, almost every square foot of our area that's not either soaking wet or drenched with salt spray will, if undisturbed for a long enough period of time, grow into forest. Before widespread human forest clearing, grassland-dependent species, such as eastern meadowlark on the left, or plants like wild bergamot on the right, were likely scarce or absent. The abundance of these species in Massachusetts was likely peaking around Thoreau's time when forest cover was at a minimum. Today, as forests have regrown, such species are again relatively scarce and of conservation concern. And their populations in New England are completely dependent upon human actions that create and maintain meadow habitat. In fact, there are many populations of wild animals whose individuals have evolved over time in ways that leave them dependent on specific human created structures. Big brown bats, for example, evolved a preference to roost communally in cavities and under the loose bark of large trees, both standing snags and live trees. As humans in the Northeast first wiped out beavers and then cut down large trees, greatly reducing the supply of tree cavities, big brown bats were able to shift successfully to a dependence on finding their roosts in another suitable microhabitat that was at the same time greatly increasing in abundance, the attics and eaves of houses and barns. And today, most big brown bats in our area and in most of the country primarily roost in such structures. Barn swallows in the top right are now largely dependent on, you guessed it, barns. And chimney swifts, who once had to settle for a rather scarce resource in the landscape, walls of caves, learned to nest successfully in chimneys and are now completely dependent on structures like that. A new resident of Boston, right? I'm a herpetologist, so I'm psyched. Our only lizard species, now wild lizard species, the Italian wall lizard, arrived in Boston about 15 years ago, having expanded its range from an introduced population in Long Island, New York, that was introduced there in the 60s or 70s. The Boston population at the Fenway Victory Gardens is, however, totally dependent upon compost piles, which provide warm microhabitats, allowing them to survive our cold winters, much colder than those in the native range of the species in the Italian peninsula and Sicily. Even in its native range, though, this lizard has likely for more than 2,000 years been largely dependent upon human structures and has long been associated with human settlement. Okay, so again, right, we humans, we didn't clear forests and create pastures to benefit meadowlarks. We didn't build chimneys for chimney swifts and barns for barn swallows. These species have been able to take advantage of humans creating habitats or structures that were otherwise scarce and limiting their populations and abundance in the landscapes. So when humans built more of these habitats, populations of meadowlarks and chimney swifts or wall lizards could expand in size. And if we decrease the number of such habitats, then their populations tend to shrink accordingly. So if we humans can unintentionally, through our actions, benefit wild animals and plants, it follows that we can do so intentionally as well. If we know enough about a species to have a sense of what types of structures and habitats specifically limit their population, We can see then if we can create more of that habitat structure and if the populations respond accordingly. Eastern bluebirds love to forage in field and savanna type habitat. And they likely benefited when Native Americans cleared forest for agriculture and settlements. European colonists created way more pasture land. However, at the same time, European colonists greatly reduced the supply of another critical habitat element that bluebirds depend on, cavities to nest in. Like big brown bats, they depend on relatively decent sized cavities, so generally in dead trees. And the extirpation of beavers and the cutting down of larger trees had a huge impact on eastern bluebirds, and their populations were likely low throughout the late 19th century. DDT and the widespread use of similar organochlorine pesticides impacted them even more. More recently, though, eastern bluebird numbers have increased sharply throughout their range in the United States. The graph on the top left are Christmas bird count data from 1941 through 2003. And that's been particularly true in the northeastern United States. The reason, there are several, but the primary one is because people have installed purposefully thousands of nest boxes built specifically for eastern bluebirds throughout the country or their range. These boxes do a very good job as stand-ins for tree cavity. More recently, eastern bluebirds have likely also benefited from the recolonization of much of New England by beavers, creating, again, more natural tree cavity. So direct and intentional human action in this case allowed eastern bluebirds, a species that was struggling and declining in most of its range, to greatly increase its abundance over recent decades. So what are some other examples of relatively inexpensive interventions that we can use to benefit species that are struggling and declining, perhaps uncommon and rare in our landscapes? This is my quick attempt at categorizing some of the types of possible small-scale habitat enhancements, which our group from Zoo New England has at least some degree of familiarity with. There are many other possibilities, and there are other ways to organize or categorize these kinds of interventions, but all of them are meant to provide critical resources to native wildlife populations that may, in some cases, help their populations increase locally. So, in common with eastern bluebirds, there are many other bird species that depend on cavities to nest in. American kestrels are species that largely forage in wide open pasture lands and grasslands. And as a consequence of the regrowth of forests and the decline in meadow habitat, have declined in New England, but they've also been harmed by, again, the same kind of decrease in cavities, large cavities in the case of these relatively substantial birds. Here, Matt Kam, one of my colleagues at the Zoo New England Field Conservation Department, checks a kestrel nest box in Essex County, Massachusetts, where it was obviously successful in attracting nesting kestrel. This particular box has had successful nesting kestrel for a number of years. And there in the top right is Matt banding one of the kestrel chicks. This gives me an opportunity to note three really important elements to think about if you're considering doing some kind of project like this to benefit declining or uncommon wildlife species. First, context matters. If you want to attract kestrels, you got to understand a lot about their natural history and their habitat needs if you're likely to do something that will help them effectively. You need to understand a good deal about what factors may limit local populations in your area. Ask yourself and research what specific dimensions and types of nest boxes the kestrels prefer. In what kind of orientation to the sun? Are kestrels likely to find this nest box where you're thinking of putting it? And most importantly, are there suitable areas of feeding habitat nearby? Again, kestrels need to feed in relatively large open areas. If you put your nest box in a perfectly nice space, but in an otherwise wooded or completely suburbanized area, kestrels are unlikely to use it. Two, beware of attractive nuisances. Ask yourself, by putting this nest box in this particular location, am I possibly attracting kestrels or whatever target species you're working with to a particularly dangerous location? It's kind of similar, I use the phrase, to the legal doctrine of attractive nuisance, which says that landowners can be liable if they attract children into dangerous situations, like having a swimming pool that's unfenced and might present a drowning risk to children. For example, we work at Zoo New England on a couple of conservation projects near Hanscom Airfield in Massachusetts. And we've long noted that in the spring, we see kestrels regularly during spring migration. There's lots of good open feeding habitat for the kestrels. And we briefly talked about the possibility of putting nest boxes there. But thinking about it, we rapidly came to the same conclusion that attracting kestrels to the edge of a busy airport was not likely a good thing. And in fact, just 2 years ago, I got a call from an airport employee and went out to help tend to a kestrel that was injured and later died after colliding with an airplane. You don't want to attract kestrels to the edges of the airport. 3, monitor the results of your efforts, as Matt is doing here. Each nest box or other wildlife habitat feature that you install or create is essentially an experiment. And you and others will only learn what works and what don't if you carefully monitor the results and monitor the use of those structures or features by the wildlife species and how they do in using it, their success in using the features that you create. And over as long a period of time as possible, because lots of things vary from year to year. Birds, of course, are not the only animals that use cavities. And as mentioned before, big brown bats, one of our more common species of bat in New England, regularly use roosting habitat and overwintering habitat in human structure. Many of our rarer bats, though, now have declined tremendously in abundance in the northeastern United States in the past 20 years because of the arrival of a killer fungus, the white nose fungus, which has reduced their population sizes in many cases by more than 90%. The construction of well-designed bat boxes and well-placed bat boxes is now regarded as likely a very important potential conservation measure to save some of these species and to help their populations rebound. They can provide maternal roosting colonies of particular importance. But to do it successfully, you need to inform yourself about the specific requirements of the bat species in your area and the kinds of bat boxes that work best for those species in your local area. For example, in a relatively cold part of the country like New England, it's important for the roost boxes to be painted in dark color and to be hung in very sunny locations because maternal colonies of bats like little brown bats need really warm temperatures to successfully raise their young. A lot of that information can be found on websites of Bat Conservation International. One of the best things you can do in a forested area is to leave standing dead trees or snags. Leave them standing. As many of you know, many species of birds, mammals, reptiles, tree frogs, invertebrates depend on snags. Even artificial snag substitutes like telephone poles, as we know, are widely used, and a huge percentage of ospreys that nest in the northeastern United States use habitat like that. If there are no good snags in the property that you're interested in enhancing in this way, you can create them obviously by killing trees and leaving them standing. In this paper by Bull and Partridge, I think from 1988, the authors carefully looked at what was the best way to kill a tree that increased the likelihood that it would still be standing in 5 years' time. And they found that topping the tree by chainsaw was by far the best, leaving all the 100 sampled trees still standing, as compared to more creative ways of killing the trees, like using herbicide or girdling or inoculating them with fungus or blowing the tops off with dynamite, which is something that I probably don't recommend trying at them. So I'm going to start in terms of habitat enhancements beyond structures. I'm going to start in the uplands and things that are possible to do in upland habitat. Again, I speak here from a particular, I know this is a broad audience. I speak from a New England, Massachusetts perspective, So you'll need to think about the context if you're in a different area of your particular part of the country. I start with uplands because relative to working in wetlands, there are fewer regulatory hurdles that you need to go through to work in uplands. So again, think of the landscape context. As I've talked about, here in New England, forest cover has rapidly increased in the past century or so. As a result, most truly forest-dependent species in New England, most, not all, are doing fairly well. However, at the same time, our landscapes have become increasingly binary. They're either forested or developed, either forested or there are lawns and houses and asphalt. There are relatively few large areas of early successional habitat, and yet many species depend on the various stages of early successional upland habitat, whether it's grassland, scrubland, savanna. So here at a site in Dunstable, where we've been working for a number of years, primarily focusing on eastern box turtles and also on eastern whippoorwills in the top left, we had an opportunity 3 years ago to work with the town and the state. The town came to this town forest and was engaged in a small project to do some selective logging and strip cuts as a way to sell the timber to get some income so they could buy other conservation areas. We said, wait a second, you can do much more good. You already have the forestry folks here. You can do much more good in this landscape, which is almost all forested, by creating a large clearing. So we laid out a 3 acre area to be cleared that was near habitat that we knew both the turtles and the whippoorwills were using. And in 1 acre of that habitat, we further asked the operators to scout the topsoil off as to the extent possible in the area and pile it in piles to further retard the regrowth of vegetation. And we're focusing over time in helping reshape this area as it grows back and is revegetated into good nesting and foraging habitat for box turtles, for whippoorwills, for scrub nesting birds like the blue-winged warbler, third from the top on the left, and prairie warblers and towhees, or eastern racers, a snake species that depends on early successional species and has also been declining. Right, as you know, in an area like New England, though, just cutting an area once and leaving it, sooner or later it's going to grow back. Even if you scalp the topsoil, it'll grow back into forest. So it requires continued maintenance. Here, John Burkholtz, one of my colleagues at the zoo, is using a battery-powered brush cutter to selectively cut some stump sprouting oaks that we had cut previously. And then our partners from Parterre Ecological went along afterwards and dabbed the resprouting stems with herbicide. And we'll need to keep doing things like this periodically to manage the area to make it the best possible habitat for whippoorwills and box turtles and blue-winged warblers. An often overlooked but very scarce habitat type in the uplands of New England is the upland thicket. Areas with little tree cover but high stem densities of woody shrubs at different heights. Birds that nest in such areas like the brown thrasher have declined greatly in abundance in New England, with a large-scale decline in shrub thicket areas in the upland. The New England cottontail, our native bunny, is now on the verge of being listed federally as an endangered species, similarly because it depends on scrub thickets. Wood turtles, which we work with extensively, heavily utilize upland thickets near the streams that they reside in during the cooler months of the year. On the bottom left, you can see, you can just make out the top of the shell of a juvenile wood turtle in a shrub thicket. And even on a very small scale, retaining individual dense suitable shrubs can be helpful. In the context, here's my backyard, half-acre yard in Concord. Can't see behind you, but on this property, I've logged over 200 species of plants, mostly native, most of which I've installed. And yet, from 30 years ago, when my wife and I acquired this property, I've carefully maintained the one multiflora rose on the property. Why? Because it provides excellent refuge in my backyard from my 2 heavily sponsored mammalian predators, my dogs, who have free use of the yard. The garter snakes, the leopard frogs, and house wrens that use my backyard often find refuge in the multiflora rows where the dogs don't want to go. Even on a larger scale, conservationists who've worked with New England cottontail have found, to their chagrin perhaps, that it's extremely hard to find native plants that do nearly as well at providing good shelter for New England cottontails as does multiflora rows. So one thing that I'll toss out is just consider, if you're working on a property, consider before you devote huge amounts of energy and resources to wiping out every possible non-native species of woody plant, whether some of those species may actually be providing kinds of wildlife habitat functions that you might struggle to provide equally well with native plants. I'm not suggesting planting species like multiflora rows, but in some cases it may be worth retaining some of them. Here's another case of a rare species benefiting from some non-native vegetation. The Zoo New England Field Conservation Department works with 4 different species of rare turtles at about 12 sites in eastern Massachusetts and southern New Hampshire. And most of the turtles at most of these sites primarily nest in residential neighborhoods. Why? These areas provide ideal turtle nesting habitat. They're in well-drained uplands. They are sunny, warm, and many of our turtles particularly like to nest right next to areas of asphalt, as in the case of this driveway, because the sun beating down on that asphalt while the eggs are incubating in the summer helps warm the nest and speeds up the development of the turtles and increases their hatching success. And these areas also may have lower densities of nest predators like raccoons and foxes and skunks, who are shyer about coming right up to houses than they would be operating in fields and other open areas at further distance from houses. So turtles very readily use habitats that we humans create unintentionally. It follows then again that turtle nesting habitat can be relatively easy to create purposely. Often it takes very little work to make suitable nesting habitat if you already know something about the specific habitats of the turtles in your area that may use that habitat. At a site in Acton, Massachusetts, where we've been tracking wood turtles to their nesting sites for a few years, we created suitable nesting habitat on a sandy slope simply by getting a small number of people out with some mattocks for a few hours, hacking out the grass and forbs that were on that slope, scraping away the topsoil, again, to slow the regrowth of vegetation, and leaving the kind of bare, gravelly sand on a slope that wood turtles particularly like. Within a year of us creating this habitat, wood turtles obliged us, 2 of them nested in one of the small scarified areas that we created. Many turtles prefer nesting on some kind of sunny slope. The moderate grades of such slopes actually help provide well-drained soils, which are good for the development of their eggs and are thus often preferred. Again, you need to know something about the particular preferences of your target species. So here I'm working with a couple of people from Parterra Ecological at that same site in Dunstable, where we're creating two long, narrow nesting mounds for box turtles. We chose a site that's relatively close to a forest edge, yet exposed to the sun to the south. And we want to be near the forest edge, where we know the box turtles commonly reside and where nesting females can be in thick cover until they come pretty close to the nesting. So, and these nest mounds were created in the course of just a few hours by having an operator of a small excavator simply dig down into the subsoil, scrape off again the topsoil, which is laden with seeds and roots, get down into the subsoil, scoop up some of the subsoil, and make it into this mound, which we compacted and made. So here are 3 of us in front of one of the nesting mounds. We made 2 about 60-foot long nesting mounds. The one on the lower left, which looked like something of a Christo art piece, we covered with clear plastic in an experiment. We're leaving the clear plastic on for 1.5 years to see if that solarization will kill enough of the seeds in the soil so that over time, it will reduce the amount of maintenance that we need to do to keep those nest mounds relatively free of vegetation when compared to the one that we left without plastic. So for a sec. All right. So if you're a naturalist and you go to a site and you want to find cool looking species of animals and plants, where do you usually head? Most people head to the edges of water and wetlands because that interface between wetlands or aquatic habitat and terrestrial habitat tends to support more diverse assemblages of species and often more rare species than the aquatic habitat, fully aquatic habitat or the fully terrestrial habitat on either side. So consequently, if you're looking to do habitat enhancements that can benefit lots of species of animals and plants, it makes sense to think a lot about working in wetlands. And even the addition in many sites of a tiny little wetland, like a bird bath, can make a big difference, as these barred owls are showing. Unfortunately, for would-be wetland enhancers, wetlands protection regulations, like I'm reminding us with the Massachusetts Wetlands Protection Act application form in the top right, can often make that process challenging. Regardless, though, humans have been in the business of creating ponds for millennia. And like in the movie, The Field of Dreams, it's generally true with created wetlands. If you build it, they will come, they will find it. I studied for some years the colonization of newly created flood control, retention and detention ponds by native amphibians, and was shocked at how quickly a number of species of native frogs and salamanders would colonize ponds, often in their first year of creation. Here, in a small retention pond that was created a couple of decades ago in a very urbanized area near the Burlington Mall in eastern Massachusetts, my colleague John is holding a jar with a state-listed fish of great conservation concern, the bridal shiner. This retention pond for some years supported what was likely the densest population of bridal shiners anywhere in eastern Massachusetts. In the UK and Europe, where, if you think about it, human populations have been dense for a much longer period of time, there's much less natural habitat. So relative to the United States, a much higher percentage of all aquatic habitat available for amphibians and reptiles is either completely human created or greatly human modified. There in Europe, people have embraced, conservationists have embraced the large scale creation of pond and wetland habitat to a degree far beyond what we do in the United States. In the UK, the Million Ponds Project, which ran from 2008 to 2012, funded the creation of more than 1,000 different small ponds around the UK that provided habitat for 52 pond and wetland species that are listed for priority conservation in the UK. Seasonally or permanently flooded wetlands can be created either in upland habitat or by deepening or damming existing wetland habitat. From a regulatory perspective, of course, it's much easier to work in upland areas outside of Wetland Protection Act jurisdiction. Zoo New England, beginning in 2009, teamed up with Mass Audubon in an effort to reintroduce New England's rarest frog, eastern spadefoot toad, to a Mass Audubon sanctuary on Cape Cod, where the species once occurred. At this sanctuary, there were no longer any good breeding sites for eastern spadefoot toads. And spadefoot toads are particularly dependent upon typically very small, very ephemeral pools in sandy glacial outwash soils. And those pools need to lack not only fish, but also even large insect predators. So they tend to be very ephemeral. Since so many small ephemeral ponds in the New England coastal plain have been lost in development, spadefoots have consequently disappeared from large areas of their known or presumed former range. So at this site on the Cape, we decided to build suitable new spadefoot breeding habitat by creating ponds. And we then, with permission from the state, of course, raised spadefoot toadlets from eggs that we collected at a nearby site through their tadpole stage and then released them. And in consultation with wetland creation expert Tom Biebeckhauser, Ian Ives of Mass Audubon, together with our group, created 8 new potential breeding pools for spadefoot toads. 5 of those, like the one shown here at the basin being excavated, were created in upland habitat, and 3, with permission from the local conservation commission, were created by deepening a wetland area that was a former cranberry bog. Here, an excavator operator hired by Ian Ives is digging out a shallow basin about 35 feet in diameter and about 18 inches deep at its low point. To make a wetland area in an upland, you've got to find some way of keeping the water from draining out, especially in sandy soil. If the soils are particularly clay rich, it may be possible to compact the clay sufficiently to hold water long enough. But in sandy areas, your only option is to put in an impermeable liner. Here, a plastic liner that volunteers are tacking down. Here's the same area 1 year later. All that was required, you can see all the coarse woody debris that we dumped in. Doesn't really matter to spadefoot toads, but it's a good feature for other native wetland wildlife species. The wetland vegetation shown here, mostly spike rushes and soft brush, and tussock sedge colonized the area on its own. No wetland plants were installed. And again, the importance of monitoring. So Mass Audubon, together with some help from us, have carefully monitored these pools over the course of a number of years, and now 2 years in a row have recorded successful breeding by eastern spadefoot toads. And through these efforts, we also helped inspire 2 similar efforts in Western Massachusetts and in Rhode Island, both undertaken by the state agencies, and both of which likewise have been successful in attracting breeding by reintroduced spadefoot toads. Like in uplands, you can create thicket habitat in wetlands, and wetland thickets are very important for many wetland species. In the lower left, one of my colleagues is holding a juvenile Blanding's turtle. Our research over the course of some years has shown that Blanding's turtles are very dependent upon such thicket habitat, particularly thickets of buttonbush and sweetgale. So we grow buttonbush and sweetgale for a couple of years in degradable root pots. Here in Inter and Regina and the Canoe has a bunch of buttonbush ready to grow. We grow them until they're tall enough so we can install them in relatively low value open water habitat just by staking those root bags down. I also quickly want to point out in the top left, the grassy meadow that you can see next to the stream. It's habitat for wood turtles. The grassy meadow is the prime habitat for wood turtles there. It's a limiting feature on the stream. The few grassy meadows provide almost all of the good habitat in the riparian area for the wood turtles in this population. And the wood turtles don't seem to care that the grass in question is non-native, it's reed canary grass. Putting coarse woody debris in streams can be very helpful for many rare species of fish, turtles, amphibians, and vertebrates. Can provide them cover from larger aquatic predators. Trout Unlimited is a group that has a lot of experience doing projects like this, and you can learn a lot from their materials. And we're going to be engaged in similar projects in a couple of streams this year. Finally, I want to cover a little bit about part that I imagine for members of the Ecological Landscaping Alliance, many of you will have particular familiarity with. You can obviously, if you want to help out uncommon or declining or rare plant species, it's obviously possible to grow those, to propagate them, and to install them in areas of suitable habitat. So I'm going to talk a bit about this, but first a bit of a caveat. We work with some state and one federally listed plant. The plant species in the top left is Sandplain Gerardia. It's both federally and state listed in Massachusetts. The species on the bottom left is New England Blazing Star, which I'll talk about a little bit. It's possible, as most of you know, to, in many cases, legally purchase seeds or seedlings of plant species that are state listed in particular areas and to plant them. You can perfectly legally do so on private property. However, if you're planning on doing something at scale or planning on planting some of these in conservation areas, I urge you to work with your state authorities. Oftentimes it's a tedious process, but permits are often necessary even to possess, depending on the context, seeds or propagules of these plants. So we've worked now for about 8 years on small-scale reintroductions of New England blazing star, our only native Liatris species in the Northeast. Species was once widespread in eastern Massachusetts, was essentially wiped out from northeastern Massachusetts. We currently maintain 6 different reintroduction sites. We grow the blazing stars from seeds that we originally obtained from a northeastern Massachusetts population, from a Maine population. We grow them either for a year or two and then plant them out and monitor them. We've planted them both in fenced areas to give them some protection, particularly from rabbit herbivory, but also in unfenced areas. And now, after years of monitoring, we find that the populations generally do well. And in most cases, the ones that are unfenced do quite well after some time as well. Blazing stars are particularly good nectar providers for migrating monarchs late in the season when the blazing stars are blooming. And on the bottom right is a picture of a quite rare bumblebee, the great northern bumblebee, that one of our volunteers took a picture of on one of our blazing stars at a reintroduction site. Increasingly, we're also turning to propagating and planting species of plants that are not state listed, but that provide the necessary habitat for rare insects. So in the case of the false foxglove oriolaria on the bottom left, it's the only host plant for rare moth, the orange sallow moth, and the fruit capsule on the top left shows a characteristic round hole, which is made by the caterpillars of orange sallow moths. So false foxgloves are hemiparasitic on oaks, and we're working with the Native Plant Trust to understand better ways to propagate this species and to plant it in the environment to hopefully help orange sallow moths. We're working at a site that has the moth in the center top. That is the New Jersey tea inchworm, which, as you guessed it, is dependent on New Jersey tea, a shrub species which is not state listed, but is declining rapidly in New England. And we propagate New Jersey tea, which can be a challenge, and are planting it out at sites to help the moths. Likewise with the frosted elfin, the butterfly on the top right, it can use 2 different host plants, sundial lupin and yellow wild indigo. And we're working with that system in the same way. Okay. And then finally, as we all know, many pollinating insects are in trouble. A simple way to help them is to create what British bee ecologist Dave Gouldson calls flower-rich meadow habitat. We were able, with the help of a local farmer and at very low cost, that was defrayed by a small grant from a local garden club, to plant 5 acres of former agricultural field that was being managed as turtle nesting habitat. Prior to this planting and starting in 2016, the area looked like in the top left, it would be seasonally plowed, and during the summer, it was covered largely by sparse ragweed. The farmers had to pay a lot to maintain this site. It wasn't very good turtle nesting habitat, and was providing little habitat for anything else. So again, for very little money, if we had more money, we would have gone for a more diverse seed mix. We were able to install a seed mix with the help of the farmers, and we've been carefully monitoring it. The last plots that we did, this picture was taken just 2 years after we first seeded it. Now it's gotten more diverse over time, and we counted 76 different species, most of them native. And one of the delights that we had is a plant species that's now really rare, almost gone from the area. Yellow rattlebox in the bottom left has really taken off at this site. We didn't plant it there by simply shifting the way that the field was maintained and stopping the plowing. The rattlebox came back. It hadn't been seen in Concord in decades. And the caterpillar that you see is a caterpillar of an ornate bella moth, which is a species dependent on rattlebox that also had not been seen in Massachusetts in a couple of decades before they colonized that area. And I'll just show this. This is from the report that we just put together showing how important it is to carefully monitor. So we take a careful look, we conduct plots, all the circles and the graphs on the left are areas where we do small circular plots and map out the diversity of plants that we find. We're manipulating experimental plots to see if we can increase the diversity. And on the bottom right, can make these little Kriging sort of heat maps to show the relative abundance of different, some of the more common plant species. Right, so I'm going to end with this. Conservationists have typically, in the United States at least, tended to take the view that we humans are somehow apart from nature, and that any influences that we have on ecosystems are always going to be negative. My guess is that other species don't exactly have that same perspective. For better or for worse, our species materially influences the lot of nearly every other living species on the planet. Some philosophers and thinkers like Bill McKibben seem to see this this Anthropocene condition that we've created as leading to inevitable ecological collapse, unless our species, frankly, either disappears or becomes radically less numerous. Personally, I favor the view of ecological philosophers and authors like Emma Marris, who at least envision the possibility of 8 or 9 or 10 billion people living in a biodiverse world. I'll end on a quote from Marris's 2011 book, Rambunctious Garden. And Marris writes, "We can't go back. We can't have this pristine wilderness that we've always dreamed of." And this sounds like a huge tragedy. It sounds like we've lost the battle. But actually, what I realized is that it can be exciting and invigorating to give up on pristine wilderness as your goal, because then you can have all kinds of other goals and you can go out and create more nature everywhere. And I asked, who is better poised at the grassroots level to create conditions that favor the continuation and conservation of diverse communities of plants and animals, including those that currently struggle in our human-dominated landscape, than the members of the Ecological Landscape Association? Thank you.
Thank you so much, Brian. That was absolutely fantastic. So we've got some time for some Q&A here. I doubt we'll get through all of our questions. So folks, I just want to remind you that once we end here, we can head over to the speakers, the speakers garden and finish up questions. So Brian, if you're willing, I've got a pile of questions here for you.
Sure.
Let me pull them up. Okay. So let's start with some easy ones. One of the questions is about bird boxes or bat boxes and whether or not painting them reduces their efficacy. I know that there's a lot of kind of school groups and young kids groups that do like painted boxes. Is there any issue with that? Is there any times where we should be just leaving them as is, or general rules to follow?
Those are great questions. If my ornithologist colleague from the Zoom, Matt Cam, were here, I would give him the question. I'll just note that I'm mostly a herpetologist and I honestly don't know. However, the good thing is that there's a lot of information out there. So,
all right. Well, in that case, I'm gonna skip a number of the bird questions we've got here, and if we've got time, maybe we'll throw them at you to see what answers you do have. But I got other questions here.
Yeah, please.
So here's a question about you showed a picture of some clear plastic over one of the turtle sites that you guys were building. Can you speak a little bit about the pros and cons of the use of clear plastic versus black plastic and kind of how you went about creating that experiment?
Yeah, so I researched it, we researched it, we looked at a few different articles, and at least one article that I found was pretty persuasive. It looked at monitored the temperatures that were recorded under both clear and black plastic over time in the sun, and also the resprouting of seeds after the plastic was removed. And it found that in general, the clear plastic was more effective, generated higher temperatures under the clear plastic, and thus did somewhat better job at killing seeds.
All right. A related question here. Have you ever used cardboard as an alternative for weed suppression? How did that work out?
Yeah, we've used it quite a bit. I've used it a lot just in my own gardening, and it works quite well. It's inexpensive. It's a lot more. It's recyclable, unlike the plastic. Although clear plastic, this thing is clear plastic. If it's fairly heavy, I think we used, can't remember. It's 10 mil plastic. Will survive a number of uses. But cardboard is recyclable, works quite well. It's not perfect. You do get a fair bit of growth of other plant species underneath it, but it works quite well. So, and it's a great resource. I'd encourage using it.
Fantastic. Can you speak to an extent as to what sort of percentage of, they're specifically asking about plant reintroductions, but I think maybe in general, what percentage of these sort of reintroduction projects are successful and how many less so?
That's a great question. And the Center for Plant Conservation has a database in which they try and track plant reintroduction projects and the results thereof. There are a number of good databases that attempt to track ecological management projects and interventions. So there's increasingly good data on that. It's always going to be skewed. My guess is that people who do things that are not successful are less likely to write them up than people who do things that are successful. So there's a bias there. In our own experience with Blazing Stars, we've been quite successful. Interestingly, we planted the Blazing Stars at 6 different kind of naturalistic sites where we do pretty little maintenance other than monitoring once we plant the species, and they've done well at those. And we also planted them at several kind of garden areas, and they fared a lot better in good native habitat than they fared in the garden areas, because they tended to be pretty heavily munched by bunnies in the garden areas, and rabbit or herbivory, if it's really intense, can be a problem for that species. So I don't have an immediate answer for you, but you can increasingly find out good information. I would direct the question in particular to the Center for Plant Conservation Reintroduction Database.
So I've got a pile of questions here about obtaining, planting, working with rare and endangered species on private and non-private lands. This is a bit of a beast of a question, and if you think it's going to take a while, we might want to just bring it right over to the speaker's garden. But the general question starts with why people should or should not be working with rare species, both on their private lands and to one extent or another on kind of public and conservation lands. And we've got 2 minutes in this room before we should move over. So you tell me, do you want to tackle that in 2 minutes, or should we head over to the speaker's garden?
Why don't we, because I think there's a lot of good discussion around that. Why don't we head over to the speaker's garden with that one? If you do want to use up the next 2 minutes, if there's a quickie, you can go there. But I think that merits a lot of discussion.
All right, let's see. I got a few more here that you might be able to kind of throw out in the next 2 minutes. There's a question about the status of Asclepias tuberosa. It was pictured next to Liatris nova anglia on a slide. Is that a rare species? Is that protected, or is that just a similar species?
Yeah, what I didn't mention, because I was making sure that I finished on time, is on that one slide where I showed we had Agellinus and we had the Liatris rare species on the left. On the right, I had a picture of, I think, New Jersey tea and Asclepias tuberosa. And I wanted to point out that Asclepias tuberosa in Massachusetts is on an informal watch list. It's a species that's designated on the state plan as of greatest conservation need, but is not protected by the State Endangered Species Act. Therefore, there are no legal prohibitions against you possessing seed and planting the seed. So I was going to point out that it's often much easier, if you want to work with uncommon plants, to work with plants that are uncommon, that have been declining, and in many cases are quite rare, like Asclepias tuberosa is in most of Massachusetts, but yet are not protected by state endangered species regulations. It's a lot easier to go that way.
Fantastic. All right. Well, folks, I want to thank you again, Brian, for your time. We will take our questions of rare species and working with them to the speaker's garden. So if anyone's unsure, if you want to get over to the speaker's garden to speak more with Brian about this and other topics, head over to the left tab in the conference space, scroll down until you see Speaker Garden Track 3. Join the video and we will continue the conversation there. So thank you for your attention. I'd like us to now get started. We're going to be speaking today, or we're going to be listening today to Dr. Deborah Landau. Deborah is the Director of Ecological Management at the Maryland, DC chapter of the Nature Conservancy, where she has worked since 2001. Her work focuses on restoration at more than 30 conservation preserves across Maryland and DC and reaching into West Virginia. She works with staff and partners to restore natural communities across the state, ensuring that they are healthy and resilient in light of an uncertain climate future. Restoration activities include native plantings, prescribed burns, invasive species control, sustainable timber harvests, and monitoring how plants, animals, and natural communities respond to these conservation actions. Deborah does everything. As a firefighter, Deborah serves as engine boss and firing boss. Deborah does do everything. Deborah is the project lead for the Potomac Headwaters Fire Learning Network. She serves as adjunct faculty at the Frostburg State University and Salisbury University. Please join me in welcoming Dr. Deborah Landau. Deborah, it's all yours. Take us away.
Thank you so much, Dan. Thank you so much for having me. I really appreciated the invite. I love talking about fire. I could talk about fire all day. So as Dan mentioned, I'm the Director of Ecological Management at the Maryland, DC chapter of the Nature Conservancy. And really what I do is ecological restoration. And over the past almost 22 years, I've really found that fire is by far my most powerful restoration tool. So I'm really excited to share some of the stuff that we've learned by putting fire back on the landscape. So first off, I am with the Nature Conservancy, and our mission is to conserve the lands and waters on which all life depends. We have programs in every state in the US and throughout North America. And in fact, we have programs in 74 countries around the world. But this is how I see the world. I'm actually from Maryland, and we've got about 30 preserves in Maryland, and we've been burning on quite a few of them. I've got little flames on the preserves in which we've been burning. We burn about 1,000 acres a year in Maryland. It's a small state and it's pretty heavily populated. And those burns can be anywhere from 10 to over 900 acres. And additionally, we assist our partners, which is U.S. Fish and Wildlife Service, the Forest Service, National Park Service, on an additional 1,000 to 3,000 acres a year. So really strong partnerships. So the Nature Conservancy has been conducting controlled burns for over 60 years, and we call that 60 years of good fire. And we're really proud of our ability to partner with government agencies, like I just mentioned, indigenous communities and others, in order to bring fire back onto the landscape and use it to restore natural areas. The Nature Conservancy's first burn was in 1962, and we're the largest conservation organization in the world involved in fire management. So when we're talking about fire and bringing fire back to the landscape, a lot of it is about what we do and don't know and what we're trying to figure out. So I'm going to talk a lot about how we determine where to put fire, how often, how hot, and kind of take you through the process, our thought process as our learning journey, really. What we do know is that fire has been part of this landscape for many thousands of years, for millennia. And most species in North America are well adapted to fire, and many are fire dependent. But our forests are altered, and many of our oak and pine communities are declining. So let's take a step back. We do know that more than half of the world's terrestrial ecosystems depend on fire in order to maintain their character and biodiversity. And in fact, almost all of North America is considered to be fire dependent. And this can mean a number of different things. It can be areas that require fire every 1 to 3 years, or areas that have evolved to having fires maybe every 100 years. But regardless, the majority of our natural communities in North America have evolved to require fire in order to persist. But how do we know how much fire and how often, and what the hardest part is often figuring out what sort of fire was going on before European colonization. So one thing that we can do is look at journal entries. And John Smith, who first arrived on our mid-Atlantic eastern shore about 400 years ago, took really good notes. He's got some really excellent journal entries that we can use, not just to see what kind of plants and trees he observed, but what he saw the indigenous people doing. And so I pulled out just one of these accounts in which he's describing using fire to hunt by the Accomack, in which he describes how they would use fire to surround the deer, and by doing so they could kill, maybe a dozen at a time or more. So really detailed accounts of what he was observing, and definitely they were very, very familiar with using fire as a tool, but for many different reasons. There's this excellent synopsis by the U.S. Forest Service on different reasons that indigenous people historically have been using fire. And so, of course, for hunting, but also for crop management. They would use it to improve fruit production. They had a really good understanding that if you burned, you would get more blueberries or huckleberries or service berries the following spring. They would use it to fireproof the areas where they lived. So they knew that controlled burns prevent wildfires. They'd use it for pest management, and I'll talk a little bit more about that later, and to clear areas for travel. So lots and lots of uses for fire. And that's one of the reasons that they were so good at using fire on a regular basis to make the area that they live more productive, more habitable. But post-settlement, even after the Native Americans were displaced in the 17th and 18th centuries, settlers actually continued using fire for many of the same reasons: to clear land, for housing and farming, to drive game, to facilitate trapping, to clear the undergrowth for travel, and to improve foraging, unfortunately for free-range hogs, but still, and to clear woods of ticks, which indigenous people had a very good sense for burning reduced tick populations. But then what happened was, in the 19th and early 20th century, the character of these fires changed dramatically. Timber operations, so timber harvesting, had shifted from local communities just cutting down what they needed to these large scale, your first industrial scale logging operations. And what would happen is they would leave tremendous amounts of slashed tree trunks and branches on the ground. And these branches would now, be drying out acres and acres and miles. And to pull out the trees, they would use these narrow gauge steam engines. So they're spitting sparks, bits of coal left and right. And what happened was this period of really intense, unnatural wildfires that caused a number of communities to burn up, and sadly, people to die. And the result was really aggressive fire suppression programs that were enacted. So what result did that have? Well, this graph is a fire history of the Appalachian landscapes, but it really can apply throughout North America. Historically, as far back as we can go, there's always been ups and downs in wildfire frequency. You'll have drought years in which you'll have really intense wildfires, and then wet years in which you'll have far less wildfire activity. But we've always had wildfires throughout history, as far back as we can go, until after those wildfires that occurred as a result of the industrial logging. Around in 1935, the Forest Service enacted a 10 a.m. rule, and that meant, it was a law, that if there was a wildfire, it had to be put out by 10 a.m. the following morning. So, but it really wasn't actually until the mid-40s, after World War II, that mechanization increased sufficiently so that the Forest Service could really go out there with their new fire trucks and effectively put out those fires. But once that was in place, we essentially saw a really serious drop in wildfire activities. And that's kind of gotten us to where we are today. But there are additional reasons why we're not seeing wide-scale wildfires today. I mean, one is active fire exclusion. If you see a wildfire, you can pick up the phone and call the fire department, and they're going to come put it out, as should be the case. You know, safety first. But there's also passive fire exclusion. So historically, when these wildfires would occur, they could go for miles and miles. They could burn for days and weeks and even months before they reached any sort of barrier, like a river or a rocky outcrop. But today, we have roads, we have buildings, we have Walmarts. That fire is going to reach some sort of barrier. So even when we have wildfires, they're far less likely to go on and on for miles. So what's the result of that? How has that changed our landscape? Well, let's just take a walk in a typical modern forest. This is what I expect to see when I go on a hike here in Maryland. I expect to see lots and lots of trees. They're pretty close together. It's kind of dark. I might see 300 or more trees per acre, but not a lot of herbaceous understory, not a lot below those trees, maybe a couple dozen of species, but it's mostly lots and lots of trees really close together. But what if this is what we should be experiencing? Early records suggest that our forests were much, much more open with fewer larger trees and a really diverse herbaceous component between them, maybe hundreds of different species underneath those trees. Back to John Smith's account, he describes the forests being so open that you could drive your horse-drawn carriage through them. So a much different landscape than what we're met with today. So what's happened? How did we go from this wide open expanse to this dark closed forest? And how do we get back? Well, surprise, I'm going to talk about fire. But increasingly, ecologists are recognizing that fire really is the critical component that's missing here in order to bring back our natural communities. So now let's start kind of putting these pieces together, how we can figure out really was fire here and how much and where. So one thing that we can do is look at pollen cores. So here's an example of pollen cores taken. This was just before they built a metro station near our Anacostia River. And this is really interesting. What you can see, so this is a really hard to read graph, and I apologize, but essentially this is depth, soil depth in centimeters. And right here at about 18 centimeters, this is around when European settlers first arrived. So if you go all the way to the right, you can see that before European settlers had arrived, there was a tremendous amount of charcoal being laid down for a very, very long time. And this suggests that there were regular fires occurring across the landscape. And those took a really dramatic decrease. You could actually see those industrial fires occurring, industrial logging, but now wildfires have essentially stopped. What's interesting, if you really wanted to get into this graph, and I won't too much, but you see bumps in blueberry and huckleberry production at the same time as these charcoal sediments were being laid down. So this already gives us a pretty good sense for the fact that fires were occurring on a regular basis pre-European settlement. Another way you can look at fire history is to look at trees, or specifically fire-adapted trees, because they don't move very fast. So this map here is showing tree ranges of fire-adapted eastern pines. So I'll walk you through it a bit. In red, we've got longleaf pines. Now, longleaf pine trees are really fire-adapted. They need fires every 1 to 3 years. So longleaf pines almost reached the Delmarva Peninsula, almost reached the Chesapeake Bay just before European settlers arrived, and then they started pushing them back. But we know that pretty close to our area here in the Mid-Atlantic, we must have had pretty frequent fires for a long time. But we look at other species. We've got pond pine, Pinus serotina, was all over the lower shore of Maryland and into Virginia, and that's a very fire-adapted pine. And there's numerous other trees. Shortleaf pine requires fire in order to effectively regenerate. Pitch pine is a fire-adapted pine, and you can find it all over the mid-Atlantic. So clearly fires are occurring regularly for these species to be here. But my favorite tree of all is the Table Mountain pine. And this is this one right here, this bubble. So I want to talk to you a little bit about Table Mountain pine. This tree is endemic to the central and southern Appalachians. You can't find it anywhere else in the world. And what's so interesting about this tree, so yeah, it's serotinous. And what that means is that the pine cones are glued shut with sap, and they'll only open after being exposed to heat, such as from a fire. And it's such a marvelous adaptation because after a fire, you've burned off a lot of the competing vegetation and a lot of the duff. And you've had this nitrogen pulse. Additionally, that black soot, that ash that you get after a fire is gonna absorb radiant energy. So it's warm. So it's the perfect condition in which for your seeds to drop and germinate. And you can take a walk on a ridgetop somewhere in the Appalachian Mountains, and you might see some big, beautiful, mature Table Mountain pines. But you're not going to see any Table Mountain pine regeneration unless you're in an area that's had a wildfire or a controlled burn. So unless we bring fire back to these landscapes, we're going to lose these trees forever. So let me talk more about these fire adaptations. One way you can look at it is as if these trees were along a fire-adapted species continuum. So all the way on the left, you've got the fire-dependent trees like Table Mountain pine. They have to have fire or else they'll disappear. But next you've got fire-adapted trees, or you can call them fire facilitator trees, such as oaks and many of our yellow pines. These have numerous adaptations that allow them to effectively survive fires. They have really thick, chunky bark, so they're physically insulated from fire. They also have long, long tap roots because often the areas in which they're growing can be very droughty, so they're very drought tolerant. But what's really cool is that they have characteristics that actually promote fire. For example, when oak leaves fall off a tree, they curl up as they dry. And as these leaves fall, they just stack on top of each other, and there's lots of air circulation between them. Then you can picture walking through the woods in the fall under an oak tree, and it's very, very punchy. So when a wildfire would sweep through an area and reach an oak tree, those leaves would pull the fire across and have it continue across the landscape. So they're really truly facilitating the fire. And very similar with the yellow pines, there's a lot of resins in their needles. So they too will facilitate the fire and can encourage it to continue across the landscape. Then you've got your fire resistant trees, such as the white pines. And these are trees that are adapted to survive a wildfire just fine once they're a little bit bigger. So a white pine, if it's a little tiny seedling, it's probably going to die in a fire. But once it's about 7 or 10 years old, it'll survive a fire just fine. So these trees are adapted to longer fire intervals. And then all the way on the right, you've got your fire in, we call them fire impeder trees. They're fire intolerant, such as maples or gums. And these have really thin, very, very smooth bark. So if a fire comes through, they're not very well insulated and they're very likely to die. But what's really interesting here is their leaves, when they fall from the trees, they're very, very flat. So if there's any little bit of moisture, it's going to get trapped between those trees for a very long time. So over time, you end up with a wet mat around these trees. So now when a fire moves through the area and it encounters these trees, it's likely to go out because these trees are ringed by this wet mat. So another way of looking at these trees is they're water loving, or another word for that is mesic. So what's happening is over time, as you've removed fire from the system, from these forests, you're getting more of these mesic trees moving into the area, and they grow very quickly and they're able to outcompete the the fire adapted trees. So without fire, as years go by, you're going to get more and more of these mesic trees. The term is mesification of the forest as it becomes more wet and has more of these water loving trees. But what's happening is with climate change, we know that we're going to get more of these longer extended periods of drought. So if we end up with a mesified forest, it's going to be far more susceptible to the stressors of climate change. There'll be more, these trees are going to be very stressed and susceptible to disease and insect outbreaks. Whereas if you have regular fires throughout an area, your entire forest will be more resilient to climate change because you'll have more of these drought tolerant species. And unfortunately, what's happening is as more and more years go by and we get more of these mesic trees in our forest, it's becoming more and more difficult to push fire through an area. And it's a lot more work. And I could get into that, into the details later if people would like. So back to how we figure out how much fire and how often. One really valuable tool that we can use is fire scars. So I talked about those fire dependent trees and how they have that thick chunky bark. In addition to the thick bark, they do occasionally get burned. They'll have an injury and it'll burn. But these trees are really good at healing over those injuries. They can compartmentalize the injury. But you end up with a little divot and it's full of sap. So then when there's another fire, it's going to burn again. But again, that fire will heal over just fine and the tree will survive. So what happens over time is fire after fire, each fire is being recorded each time that tree heals over. So you end up with these wonderful recorder trees. And this one on the left, it has recorded, and this tree is living, it's recorded 1, 2, 3, 4, 5, 6, at least 7 burns in this tree are now captured. And what you can do is you can take a cutting from these trees, and many of these cuttings were taken from dead trees, and I can explain later if people want how we age them. But once you take a cutting, you can pinpoint exactly when those burns had occurred. So this one tree here, this was the Table Mountain pine. It experienced a fire in 1814, 1840, 1876, 1885, and 1895. So when you have enough trees from a forest with these fire scar records, you can start to put together how often these wildfires were occurring. And not just the years, but what's really cool is you can look at where that fire scar sits, whether it's on the late wood, which is those dark rings that occurred during the dormant season, or the early wood, which is the light rings that came during the growing season. So now you know not just how often and what years fire were occurring, but what time of year. So a tremendous amount of information that you can get from these fire scar records. A really interesting study that occurred in Western Maryland, it's a sad story, but fascinating, is a clear cut was done of an old growth forest. They cut down a huge stand of trees that were over 400 years old. And a researcher went and he was looking at these ginormous stumps and he could see fire scars. So he collected 20 samples from these stumps and he was able to record 42 fires that had occurred between 1616 and 1959. So with all of that data, he was able to establish that 400 years ago, fires were occurring at approximately an 8-year mean fire return frequency. So that's a ton of information. Also really interesting, only 4 fires occurred since 1930 and none have occurred since 1960. So lots of really good information out there. We're losing it as these logs decay, but we're working hard to capture them. So we've established that fires used to occur on the landscape, and they are important for our natural communities. But fire is hard. You have to put in fire lines, you have to get a crew together, you have to get your equipment, you have to get your permits together. So a lot of people say, well, you know, why don't you just cut down the trees? Can't you just log as a fire surrogate? And there you're letting more light to the ground. And isn't that about the same? So, you know, maybe. So here's an example of where we've tried that. So we have an area that was a wetland, and this is on our Nasawanga Creek Preserve, which much of it came with loblolly pine plantations, so just rows and rows and rows of pines. But we had a drought year, and we were able to come in and clear cut it and take out all of those loblolly pines. And the results were really exciting. We found after this clear cut 7 white-fringed orchids that we hadn't seen before, and a handful of these beautiful yellow-crested orchids. So just by removing the trees, we did in fact find a really exciting plant response. But then we came in and we burned. And after the burn, it was so much more exciting. We had over 50 of the white-fringed orchids, 20 of the yellow-crested orchids, and 3 of these extremely rare Camby's bog orchids, which is a cross between the other 2. And we looked at the records, and this Camby's bog orchid hadn't been seen in Maryland for 18 years. So we went back to see when it had been seen last. And 18 years previously, it had been found on the same site after a wildfire. So there's a wildfire, the bog orchid appears, and then no fire, and it blinks out. And then 18 years later, we burn, and just weeks later, it appears. So there's so much more involved here than just bringing light back to the ground. And, you know, we don't really truly know what it is. It could be that heat pulse from the fire. It could be that nitrogen going into the soil. It could be a chemical reaction in the smoke. What we know, though, is that these organisms are really responding positively to fire. So there's more going on than we understand, but it really brings home the importance of fire. So I'm going to switch to now some, let's talk insects. At the same preserve, at our Nasawanga Creek Preserve, we have Cicindela abdominalis, the Eastern Pine Barrens tiger beetle, which is critically imperiled in Maryland. And it's a really interesting insect. It burrows down into the sand. So it likes this really fine sugar sand. And it's pretty cool. When it's in the hole, all you see is the top of its head. And it waits till insects walk by, and then it jumps out and grabs them and takes them in. So when I see, just an aside, an insect that's evolved like this, that to me screams fire tolerant, because clearly you can just picture a fire going through this area, and this insect is completely unaffected. But anyhow, this tiger beetle is disappearing from the landscape, and there's only a handful of places left where it occurs in Maryland. So we wanted to restore it. But the only place that we had it on our preserve was right on a sandy road. So we were concerned that it was just going to get run over. On either side of that road was a loblolly pine plantation. So what we decided to do, so here's the sandy road, and you can see how sandy it is, but there's nothing but trees on either side and nothing but pine needles. We did an experiment, and we tried clear cutting some sections of that sandy road. We thinned some sections of the sandy road. In some areas, we left trees but cut behind them. So we did a number of different manipulations, and we were extremely careful not to bring any logging equipment down that road. The skidders had to go a mile around it to pull those trees off. And the results were really disappointing. Despite all of our cares not to squash the beetles, the population just absolutely plummeted for several years. So we were really worried that we devastated our population. But then we came in and we burned, because one of the things that happened when we thinned and clear cut is it let more light into the ground, and we got a lot of these nice grasses that pull fire across. So here we are burning those areas, and you can see how sandy it is behind. And after we burned, it was great. So the population just went up and up and up every year. And not only the population go up, but those beetles started to move off of the road and onto the surrounding area. So in white in the center of the slide is that sandy road. And you can see our different experimental blocks, some that we clear cut, some that we just thinned, some that we left a buffer and then clear cut or thinned. None of which had any positive effect, But once we started burning, we started finding beetles moving further and further away from that road. So absolute success only after we reintroduced fire. Another example, which is, again, good and bad. This is all a matter of balancing and trying to figure things out. Once we started burning, we found that our wild lupin populations really increased, and that was really exciting. The lupins love fire. Unfortunately, deer love lupins. And so the deer were absolutely, this is a lupin that's been bitten off by a deer, clobbering all of our lupin. Basically what they're doing, here's an experiment where we caged our lupins, and here's one where we didn't. They were eating the flowers as soon as they bloomed. And the problem there is not just that we're not getting our lupins, but the lupins are a host plant for the frosted elephant butterfly. And frosted elephant is on the verge of being listed as an endangered species. And we're trying really hard to keep it off that list. And this is the only place in the mid-Atlantic that the frosted elephant occurs. So what's happening though, so the frosted elephant lays its caterpillars on the plant, and the deer were essentially eating the caterpillars. So we increased the host plant, we brought in the host, the butterflies, but now we're killing them because of deer. So now we're trying to find a balance between, we've got some exclusion cages for the lupin, and we're manipulating our fire cycles to try to find just the right balance so we get more lupin, we get more butterflies, and we can have some control over the deer. So, but again, it's a balance. It's just a matter of kind of figuring it out, and we're getting there. Another insect example that's impacted by fire is ticks. So with climate change, we have seen really increased spread of many species of ticks. I'm going to specifically talk about the black-legged tick, more commonly known as the deer tick, which has absolutely been spreading north and west. And with it comes many of its associated diseases. Most people know about Lyme disease. And numerous studies have found, including this one by Elizabeth Gleim, that if you're burning an area regularly, and these need to be large burns, that you can reduce tick populations by up to 98%. And so you're dropping tick populations and, of course, Lyme disease as well. And back to the indigenous people's use of fire, they understood very well that burning an area regularly reduced tick populations. So it's something that we've just forgotten, and now we're figuring it out again. So in Western Maryland, we're working with Frostburg State University to do a study at our Sidling Hill Creek Preserve, where they're looking in areas that we've burned and haven't burned yet. So there's 2 students, and what they do is they drag these white sheets through the woods and they pick off the ticks. And so they're counting ticks as well as seeing how many are infected with Lyme disease. Lyme disease being really, really new to Western Maryland. And sure enough, preliminary results are showing that tick numbers and virulence is in fact lower in areas that we've been burning. So really exciting results. So now I'm going to switch gears and talk a little bit about wetlands and fire. So a lot of people don't realize that wetlands burn really well, and they need fire in order to maintain their character. What happens in many cases is when you don't burn a wetland, very quickly trees will move in and become established, and those trees will grow big, they'll draw up the water, and the wetland will essentially disappear. So we've regularly been burning many of our wetlands, and I just have this series of pictures to show you how quickly the vegetation responds. So this is our Dorchester Pond Preserve. It's a Delmarva Bay, which is a seasonally filled wetland, similar to a Carolina Bay or an ephemeral pond. And here it is in March with the dead grasses before we burned. Here's the burn. We burned in April, and here it is immediately after the burn. And by June, that pond had just absolutely filled with grasses and sedges and rushes and such an amazing diversity of wildflowers. So quickly. So to me, this just again screams fire adaptation. How quickly those plants respond to the fire. I'm going to give you another example of where we've been burning in Delmarva Bay. This is at our Pristine Pines Preserve. And it has a globally rare plant, Canby's dropwort, which is G2. It's globally rare. And this is the only place that it occurs in Maryland. The next closest population is in the Carolinas. There used to be a population in Maryland, but it blinked out. And when we started managing this pond, we were down to only 2 plants. And as I described with the previous slide, if you don't burn these open wetlands regularly, you won't kill off tree seedlings that are always, seedlings are always becoming established in a pond. But over time, these trees get bigger and bigger, and they shade out the herbaceous vegetation. And as they get bigger, they take up more water through evapotranspiration, and you can eventually lose these ponds. So in the early 2000s, what we started doing is just cutting all those trees out of the pond. It was full of trees, so we cut them and we dragged them out. That was fairly successful. We got population up to, a couple hundred, but it really wasn't going anywhere. We knew we really wanted to burn, but we really did not want to put in a fire line, which is what you usually do when you're ready to burn, is you cut in a line so that the fire doesn't pass it. But this is such a sensitive site that we just were not comfortable doing that. So we wrote a prescription that said, so that the sunny open pond is surrounded by woods, by dark closed-in woods. And we wrote a prescription saying that if we burn a day or 2 after fire, the woods will be too wet to carry fire, but the grasses will carry fire. So on that day we can burn, and the fire should go out when it reaches the woods. So we did that, and it was spectacular. And the results were just so exciting. And after, I've got 2 burns here, we've actually burned a 3rd time since, and the population just skyrocketed to almost 4,000 plants. And not only has the population increased, but the plants are starting to spread, which is so exciting. So I want to show you a video of what that actually looks like. So here's Dorchester, is the pond, and this is me in the foreground burning, and that's our burn boss in the middle. And right here, if you can look at the lower right-hand corner, you can see how dark it is. And that's the shade from the trees. The trees are right behind me. And it's doing exactly what we had hoped would happen, that as that fire reaches that shady forest edge, it's just going out on its own. And then in the foreground, in the far side of the picture, you can see another person lighting fire. So we had very little actual ignition going on. We just had 3 lines of ignition, mine on this side, 1 person on the far side, and 1 person went down the middle. And these grasses just pull that fire across the pond, which really shows you how fire adapted this vegetation is. And what's really cool is the sphagnum moss was still wet. It was still holding water. So even when the vegetation is damp underneath, those grasses just burn. And that fire line, that ecological fire line, those shady woods held the fire perfectly. So this is an example of a way that you can do a very low impact burn and have really fantastic results. And again, just shows you how fire adapted these communities are. All right, now I'm going to switch to animals because we're supposed to be talking about wildlife. I'm going to start with just this picture of a killdeer nest that I happened across when I was looking at the results of a huge wildfire that occurred in the Dismal Swamp in 2011. And it's incredible how well camouflaged these eggs are to this fire-scarred landscape. And when you see things like this, again, it just really shows you that these birds have obviously evolved in areas that have had frequent fires because these eggs just blend in so perfectly. So I'm going to transition now to some bird studies that we've done to look at the effects of our burning with our bird communities. So I'm going to go back to our Nassawango Preserve. This is a 10,000 acre preserve on the eastern shore of Maryland, in which we set up these acoustic monitoring boxes. And we compared these open areas, these are areas where we've been burning regularly, to these unburned, more closed in areas. This is what it looks like before we started management. You can see this loblolly pine plantation, nothing underneath, but pine needles, or else really closed in and dark. And the results from the study have been really, really exciting. So this is the pre-dawn chorus. This is from 4 a.m. to 10 a.m. And we run this, it captures sound every 2 minutes. And in red are the results from the open area, and below it, I don't know if you call it blue or green, are from the closed areas. And the diversity and the abundance, so the number of birds and the number of species are much, much higher in areas that we've been burning regularly. And this could be for a number of different reasons. The woods are more open. It's easier for the birds to have sight lines when they're flying, either looking for prey or searching out their nesting habitats. So lots of different reasons, but the end result is when you burn regularly and you open up these areas, your bird diversity increases tremendously. And some examples of some of those species that came in the areas we've been burning were brown-headed nuthatch, blue-gray gnatcatcher. We had pine warblers come in. And throughout the areas that we've been burning, we've had a huge increase in our bobwhite quail populations, which is really exciting. Loads of turkey and lots of night jars, including whippoorwills. And I don't know if any of you have heard whippoorwills at night. They're pretty loud. And the funny thing is, we figured out that they were there because we're not usually there at night. We had a burn crew stationed on the preserve for several months, and they would complain that those birds go on all night long. And we're like, you mean whippoorwills? And they're like, yeah, they're the worst. And we're like, that's awesome. So really exciting results in the bird communities just from our burning. Another really unexpected find was our population of red-headed woodpeckers really skyrocketed in these areas that we had been burning regularly. This is areas that we've been burning the longest in the biggest area. So we researched this and we found numerous papers that said that yes, red-headed woodpeckers really like burning, but they need areas that have been burning in a mosaic. So maybe an area here that burned last year, but one here that burned 3 years ago, and one here that burned 5 years ago. They need that diversity of burns in order to thrive. And that's exactly what we had been doing at our preserve. So I'm going to show you just some really fun, gorgeous pictures that our burn boss, Gabe Cahalan, has took. And I invite you to come visit our Nasawanga Creek Preserve, and you will be almost guaranteed, if you come at the right time of year, just an amazing aerial show of these spectacular red-headed woodpeckers that are just all over the preserve now, and it's just such a treat. All right, now I'm going to switch to bats. Bats is a very similar story to birds. Bats really need areas that have been burning regularly, but with that mosaic. Bats really like to rear their young off of where bark is sloughing off of a snag, so a tree that has recently died. It's a perfect place for them to rear their pups. It's warm, it gets a lot of radiant energy from the sun, and it's pretty safe from predators. And this is an Indiana bat, which is federally listed in a pine tree. But again, similar to the habitat that the red-headed woodpeckers need, this is a really ephemeral habitat. So you have to continue burning across the landscape and have a mosaic of burns in different areas in order to continue the habitat that these bats need. And we've had 2 studies looking at bats populations on a preserve where we've been burning in areas that have not burned, and consistently we're finding that bat populations are higher in areas that we've been burning. In addition to the sloughing off the bark, the habitat, also similar to the birds, the bats really like it more open. It's easier for them to hunt. They have better flight corridors. So lots of benefits just from the burning. I'm going to go back to the birds and talk a little bit about an assisted migration experiment that we've been trying. And talk about red cockaded woodpeckers. So red cockaded woodpeckers are also federally listed, generally not found any further north than Virginia, although historically they were in Maryland. And they like longleaf pine savannas. So longleaf pine trees, beautiful big fire adapted pines that when they get mature, they get red heart disease, a natural occurrence. And so the woodpeckers love to nest inside these trees that get these cavities inside. Studies have shown that there's been increased mortality in red-cockaded woodpecker fledglings because of unusually hot springs when they're in the chick stage. So increasingly, springs are hotter and mortality has been higher. So it really shows that these birds are going to need to start moving north. So what we've been experimenting with is we've brought longleaf pine back to Maryland. Historically, we think longleaf pine were here, but they're gone. So we've been planting longleaf pine and burning them regularly. They're doing really well. We have many of the longleaf pine associates already in Maryland, so that we're hoping that if eventually the birds need to be moved up artificially in order to increase their survivorship, we'll kind of have a starter forest of longleaf pine already in place. So I want to finish off with showing you what these burns look like, because a lot of times when I talk about controlled burns, people think, oh, scary, big flame lengths. So not necessarily. So this is what a burn looks like in an area that's burned frequently, say on the coastal plain. So this is about 20 minutes worth of video right here when you're looking at the actual fire. Flame lengths are maybe 2 feet high. You could almost step right over it. And now this is speeded up to about 3 months. And very, very quickly, you get this amazing resurgence of growth, this crazy green like you saw in that Delmarva Bay pond I showed you. So the vegetation responds so quickly. And the burns, again, it's a controlled event, are pretty, it's not a scary situation. That's what I'm trying to say. So finally, I'm often asked about carbon emissions, and people say, well, isn't it bad? Because you're putting all that smoke into the air. Isn't that bad for the environment? Well, so yes and no. So I'm going to separate control burns, which is what we have on the left, from wildfires, these mega fires, which is what you have on the right. So when you're doing a controlled burn, you literally have to write a prescription. You have to write a plan that says it's not going to be too hot, it's not going to be too dry, it's not going to be too windy. You've got your containment, you've got your fire line. So you're only going to burn in the place that you intend to burn. And you will kill some trees. You're going to kill some of those thinner barked trees that I talked about, like your gums and your maples. But the trees that remain are going to grow bigger, faster. And when you burn off that herbaceous vegetation, that's going to come back very, very quickly. The picture you see below is this same site just a few months later. You get, again, that crazy green up. So that's locking so much more carbon now into the system than you released. But what you don't see is the roots of those herbaceous plants grow so much deeper and bigger after a burn. So now you're locking even more carbon into the system. And finally, not everything burns. Some of the big logs, down trees or branches, they don't always completely burn. So you end up with a lot of charcoal or pyrogenic carbon. And that eventually works itself into the soil over time. So now you have carbon that's locked into the system for millennia. So now let's look at the other side. On the right side, I've got a picture of one of these mega fires that we're seeing out west. And these are not natural fires. These are the result of fire suppression over decades, even 100 years, in which you have that situation where the trees are so close together and there's so much fuel on the ground that when you eventually have a fire, and you always will have a fire, the trees are completely consumed and the fire is just jumping from treetop to treetop. And it's so hot that it's burning all of the organic material. It's burning down to mineral soil. So you're even losing your seed source. So this system is going to take a very, very long time to recover. But we're not just talking trees now. When you get these mega fires, you're burning up communities. So houses and cars and refrigerators are burning. So now you're releasing all of these petroleum products into the air. And again, this is going to take a tremendous amount of time to recover. So hopefully with more prescribed fires, we'll be able to reduce the number of wildfires and come back to a balance. So that's all I've got. And I'm happy to take any questions if there's time. And thank you.
Deborah, thank you so much. That was a fascinating talk. We do indeed have some time for a few questions. I'm gonna, yes, no, I'm not muted. I'm gonna cap us at about 5 minutes here, and then additional questions we'll bring over to the speaker's garden, just so we can keep this whole thing moving. So, questions. I threw a couple of these questions in myself. First one I've got here is, can prescribed fire be used as a tool for invasive species management? Is that something you have experience with?
Oh yeah, that's a terrific question. So if anybody can guess my answer, it's complicated. So I can give you an example. I know we're short on time, but there's a preserve where we had a very fire adapted site where we were burning in the spring. And after a couple burns, we had a terrible infestation of Lespedeza, Chinese Lespedeza, and it absolutely took over. So we realized after the fact, we read up, and that if you burn in the fall when it's in seed, you can burn up its seed source and reduce the population. So we switched our burn prescription and started burning in the fall instead, and we were able to bring that population back down. So that's an example of when we burned, we actually really helped the invasive species when we burned at the time of year we wanted to burn. So we switched time of year, and then we were able to control it. There's a few other examples, like on the Eastern Shore in our marshlands, we have a lot of Phragmites. And there you can control Phragmites with fire, but you have to combine it with herbicide. You kind of have to give it this double whammy. So it really depends on the species. Some invasive species, unfortunately, do really well with fire. So it's complicated. It's really a species by species answer.
Well, that's fair enough. This is a complicated topic. So another question, this is about return intervals. When you're determining a return interval for a site, is it purely based on the historical return interval, or do you sometimes base your interval on some other goal that you've got for the site?
Wow, that's a great question. So when we're planning a burn, it changes. When we first go into an area, we'll call that a first entry. That burn is different because we have a lot of fuel on the ground. It's more mesic often. So often that first entry burn will be a really, really light burn, maybe just a few days after rain. We won't try to push the fire too hard through because we don't want to, sometimes that first fire can be too hot. So I'm getting a tiny bit off topic. But just to give an example of some of the negative stuff that can happen is sometimes when an area hasn't burned for very long, you get a thick layer of duff that builds up. And some of these big mature trees, the ones you're really trying to protect, they'll send little feeder roots up into that duff. So if your first burn is hot, you can actually kill the trees that you're trying to restore. So those first entry burns can be very frequent but light. So that you can slowly burn off that duff and lower your amount of fuels. Once you've established that, once you've gotten it more open and worked through that duff, then you start to work on your fire frequency. And we, again, it depends on the community you're trying to restore. I showed a lot of pictures from our coastal plain, which is very open and flat and grassy. And there the fire frequency might be every 3 years. That's kind of what we're finding works really well for us. Over time, we might extend it to every 5 years. in Western Maryland, we're finding that maybe every 7 years is working for us, which is about what we're seeing historically. But again, for starters, we're burning more often, maybe about every 3 years, because those first few burns are really slow and cautious. So it evolves over time. So that felt like a roundabout answer, but it's another way of saying it depends.
All right, I'm going to throw some what I think might be quicker questions at you, and then we'll take, I got some really good ones here that I think we should take over to the speaker's room, but maybe a quick one. Are trees with shaggy bark specifically good for bats? The questioner was asking specifically about shagbark hickories.
That's a great question. I don't know. It's funny because I've actually seen bats in shagbark hickory, but I don't know if they're just hanging out or actually raising their pups, because I know when they're raising their pups, they really need it to be a little bit more enclosed. They need that shelter. So it might be great for them to hang out in. I don't know if it's necessarily appropriate for them to rear their young.
All right, tell you what, I'm going to ask this next question, and I'll ask that you, instead of answering it here, we'll take it over to the next room. But just for everyone who's still with us, to give you a heads up as to what you'll miss if you don't join us in the speaker's garden. The question here is, are there ways to self-replicate some of these procedures in a residential setting? Many installations, such as like a half-acre meadow or grassland, are within 50 yards of homes and structures. And the question is, what can we learn from, your topic and what you've been speaking about, and how much of this or what version of this can we take into these residential settings? And I'll simply say that, folks, if you want the answer to that question, come join us over in the speaker's garden for track 3. We're going to head over there shortly. Deborah, I will join you there in just a moment. Thank you again very much for your knowledge. This has been absolutely fantastic. Folks, if you enjoyed this as much as I did, I recommend that you go for our session reviews. You can check in there. Let us know what you think about this. We really welcome the feedback. The next session in this room will reconvene at 2:40. That'll be Heather Holm, who will be discussing restoration, ecosystem functionality, and biodiversity in a changing climate. If you can't get enough of fire, I saw Heather mention in the chat that she will also be talking about fire. I don't think it's going to be all she's talking about, but it'll be coming up again in our next session. So for the rest of you, if you want to hear about what version of fire we can do in the residential setting, come on over to the speaker's garden. Thank you all very much.
So welcome back, everyone. Thank you for joining us today. We're in the 3rd session of the Building Relationships That Support Wildlife track, otherwise known as track 3. So welcome to track 3, welcome back. And this is the 29th annual ELA conference. My name is Julie Snell, and I serve on the ELA Board of Directors, and I'll be your host for today's 3rd session. So once again, we really do encourage you to click on those cameras. We like to see those smiling faces. It's nice to have that eye contact, especially at the beginning. It's just nice to kind of foster that online learning community. So we're happy to see you. Give us a wave. There you go. Excellent. We're so happy to have Heather here today with us. Heather Holm is a biologist, a pollinator conservationist, an award-winning author. She passionately informs and educates audiences nationwide through her writing and many presentations about the fascinating world of native pollinators and beneficial insects and the native plant communities that support them. Heather is the author of 4 books: Pollinators of Native Plants from 2014, Bees 2017, Wasps in 2021, and Common Native Bees of Eastern United States 2022. Both Bees and Wasps have won multiple book awards, including the American Horticultural Society's Book Award in 2018 and 2022. Heather's expertise includes interactions between native pollinators and native plants, and the natural history and biology of native bees and predatory wasps. Her work is featured in the New York Times, the Minneapolis Star Tribune, and many other local publications. Heather is also an accomplished photographer, and her pollinator photos are frequently featured in print and electronic publications. Heather is a national honorary director of the Wild Ones, and she also serves on the board of the following nonprofits: Friends of Palaine Nature Preserve and Bird Sanctuary, Friends of Minnetonka Parks, and her local Wildlands chapter, Prairie Edge. In her spare time, if she has any, she's an active community supporter, writing grants and coordinating and participating in volunteer ecological landscape restoration projects. Her latest project is a 13-acre oak savanna restoration that sounds very cool, that will provide thriving habitat for pollinators, birds, mammals, and passive nature-based opportunities for people. Please join me in welcoming Heather. Yay, Heather.
Thank you. Thank you, Julie. Great to be here. I will get my presentation up, and given that introduction, you'll probably be surprised to hear I'm not really talking about pollinators for this presentation. I actually put this presentation together based on a lot of my volunteer ecological restoration work. And if you just tuned into Deborah Lindau's talk previous to this one, I have a little bit of repeating information, but I hopefully just build a better foundation on this idea of what are fire-dependent systems. So I'm going to really be talking about the things that I have learned over the last 20 years restoring landscapes, and also some of the challenges. And at the beginning, some of those challenges were because I didn't understand the systems fully that I was working in. And until we really understand the ecological history of the land and also the profound influence of Native Americans and the role of fire, we really can't successfully restore land no matter where we live in the US. So I'm going to be starting off by looking into the past. I live in Minnesota, so I will have some Minnesota related examples, but thinking about how do we plan for climate change no matter where we live, whether it's in the Midwest or in the Northeast or wherever you may be participating from today for this presentation. And then I want to look into the future, because really, if we're restoring land or doing habitat or conservation gardening projects, we need to be thinking about resiliency. And are these landscapes that we're designing and planting going to withstand the future warming of the climate? And also the really rapid change in perhaps what we consider to be the normal plant communities that occur. So I want to dive into sort of a better understanding of this idea of a prairie to forest continuum. And prairies can also mean meadows if you're in the Northeast, but really these grassland and forest dominated systems. I also want to look at how these different plant communities have the capacity to sequester carbon, because that's one thing we hear is in order to combat climate change, we are told to plant trees. And that may not be a suitable recommendation depending on your specific goals. And then how do these systems really, how can we manage them and steward them and restore them so that we are sort of maximizing ecosystem functionality? So I'm going to talk about all of these things, in addition to how all of this relates to oak ecosystems. So as I mentioned, I'm in Minnesota, smack dab in the upper Midwest. And you can see I've outlined the state of Minnesota on this level 2 ecoregion map. And our state has 3 primary biomes. We actually have 4, but this level 2 map is showing the 3 primary biomes. The middle green biome is largely deciduous forest that you are familiar with if you're in the Northeast. The beige area in the southwest part of our state is prairie and grassland. And then the light blue is more of a boreal ecosystem. So if we look at that from the standpoint of, okay, that's our existing conditions, what is going to happen with climate change? And the modeling is demonstrating where I live in the Twin Cities area, which is in that green, lower green section on the eastern side of the state. Our climate is projected to be the same as Manhattan, Kansas. So we are going to push into a hotter and drier type scenario. And so given that modeling, thinking about what sort of plant communities that still exist in my state today and how they may be equally as resilient going forward with this projected change in climate. And this is just a blow up of sort of the center section of the state that I live in, again, showing the 3 primary biomes, the boreal forest to the northeast that wraps around the north side of Lake Superior, that middle zone that is characterized as a deciduous woodland or forest, and then prairie pushing in from the west, from the southwest portion. This map is called the Marshner map, and it was generated by Francis Marshner, who was a cartographer. And basically, when the Midwest was laid out, I have lived in the East and I'm familiar with the non-grid system, really some of the primary roads being former cart paths. Here in the Midwest and much of the country, the land was surveyed into this grid system. And while surveyors were doing so, they were noting in their survey records specific bearing trees that were at the intersection of the certain size plots. And so these bearing trees were noted for species and size, and also there were often general descriptions of the environment or specific plant community that the surveyor was moving through. And so the map is called the Original Vegetation of Minnesota, and there are similar maps for other states. I would like to say original in quotes because it's, again, a certain point in time and it's representing what were the plant communities at the point of European settlement. So it is by no means an original vegetation map. But what's interesting is Francis Marshner, who was the cartographer, never actually even came to Minnesota. He was based in Washington, D.C., and he really just pored over the survey books, the surveyor books and records, and was able to create this complex map of plant communities by using that information. But these maps, of course, are very valuable. It gives us a glimpse at a certain point in time to understand the land and maybe some of the influences of Native Americans, but not entirely. And this tension zone that sort of sits in the middle of this warm, dry prairie system and cool, moist boreal forest has really shifted over time since the last glaciation. So when we had a period of warming and drier conditions, that prairie would push up into a more northerly part of our state. And then when we have a period of cool, moist conditions, that tension zone shifts. Now I live within the tension zone in that brown area, or that kind of rusty red colored area. And that is primarily oak savanna. And we do have green within that tension zone, which would have been more closed canopy forest, but I'll talk a little bit more about the differences between the two. But with any plant community, not only is it influenced by amount of precipitation and evaporation, but also we have to keep in mind topography and also geology and soils. But the one piece that many people don't think about is the cultural and biological influences. So with the history of Native Americans setting frequent fires throughout North America, and particularly in the Midwest, this really influenced the layout of these different primary plant communities. And the second piece is grazing animals, which we've largely lost or replaced with European type domesticated grazing animals that do not have the same influence or outcomes on these systems. So we all know the story of what's happened to our landscapes since colonization by Euro-Americans. What often gets missed is what has happened with the fire on the landscape. It's really largely been erased. There's mostly fire exclusion, and that it was due to what Deborah talked about, not only prohibition laws, but just the changes in Native American populations due to the introduction of infectious diseases, wars, And then, of course, the signing of treaties that they were essentially ceding their ancestral lands to the government. And then following that, of course, was the extirpation of these keystone grazing animals, such as bison and elk. So the remaining landscape today, and going forward, it became overgrazed. The Europeans were very attracted to these grassland systems, large-scale conversion of the natural landscapes for human uses, agriculture, housing, etc. And then we've had a real increase in annual precipitation here in Minnesota, which has largely influenced the mesophication of some of our oak ecosystems. And I'm going to talk more about that through the presentation. And again, talking about all of these factors as how it has increased the invasibility of the natural system. So they've become more susceptible to these non-native invasive plants that have been introduced since Euro-American settlement. So I really like to stay away from the idea of forest succession, because that's an idea that is derived from the fact that humans didn't have any influence on the land historically. And I like to think of that as kind of false. And the whole sort of thread through my presentation is really to highlight that landscapes have always been maintained by humans. And fire was a primary tool in doing so. So this prairie to forest continuum could represent different parts of the country. If you were in the desert Southwest, that prairie would be a cactus forest. And then as you went up higher in altitude, you would also find savanna-like systems, woodlands, and then forest at the top of a mountain. So these fire maintained systems are very, very important and also very diverse. And what gets lost, I think, is that these Native Americans were really significantly influencing the land and all of the plant communities with their regular use of fire. And this is a really interesting read, this book called Forgotten Fires. It goes through each of the regional areas of the country, talks about the historical accounts of early European explorers and settlers. And as Deborah illustrated beautifully, looking at the tree fire ring scars to better understand the frequency of fire that where it was lit in a given area. But this book really does illustrate that most of the continental US was burned with regular frequency. So the idea that at first European contact on the eastern shore of North America, the land was not forested, it was largely open and described as park-like. And this was a landscape that was influenced by fire. And fire frequency, and Deborah talked a little bit about this, it can really influence what the plant community structure looks like. So if you have anywhere from a 2 to 5 year fire interval, that is so frequent that it will limit any woody plants from getting established. So that is going to maintain a grassland system such as a prairie or meadow. When you have a fire frequency from 10 to 20 years, that is enough sort of break time for certain fire tolerant tree species such as oak to become established and develop thick enough bark in order to withstand the next fire that may occur anywhere between 10 and 20 years. So those systems start to turn into savannas and more open woodlands, but they still remain fire adapted. And then when you don't have fire whatsoever, which has really happened in a lot of our spaces since Euro-American settlement, fire suppression, 100+ year fire interval is going to result in a closed canopy forest. And it's also going to have a predominance of species that are fire intolerant. And I'll provide some more examples of that later. This is a map from a 2012 study, and they looked at historical accounts and also the fire scars on trees throughout the country. And they modeled that and created this map, which predicts the fire frequency throughout the US pre 1850 settlement. And the bright red areas were fire frequency of anywhere from 2 to 4 years, transitioning into the orange and yellow. So anywhere from maybe 8 to 12-year fire frequency. Greens were anywhere from 18 to maybe 25-year fire frequency. So those would still be maintaining open fire dependent woodlands. And then even into those blue spaces up until a 50-year fire frequency, you'd still be supporting a rather open woodland system. So just those pink and purple sections on this map are really representing spaces that were, or sites that were where there was fire exclusion. And if you look at it, well, that makes sense. A lot of these high altitude areas on mountain ranges, perhaps cool east and north facing slopes that would inherently be places that fire would not have enough fuel in order to run through the system. So the idea that the landscape was all forested pre-settlement is largely false. And Deborah had some really nice examples in addition to what I'm going to mention, but why did Native Americans use fire? Well, they used fire to really maintain these grassland systems because they knew some of the primary mammals that they were hunting were dependent on grasses, including bison and elk. So they also used fire to keep the hunting animals into a certain area, making it easier for them to hunt. They also used fire to get rid of that underbrush and ticks, as Deborah talked about, and it allows them for easier travel through some of these more treed landscapes. It also gave them better sight lines, and that's sort of a primal trait of humans. We like to see enemies coming on the horizon, and so these fire maintained much more open systems. And it also that the Native Americans were really excellent stewards and understood their food needs. And they knew that with fire, it would promote the growth of, and in addition, improve the nutritional quality of many of the foods that they foraged, in addition to the mammals such as bison that they may have been hunting. So one great example is blueberries. Blueberries, the ericaceous plants that grow in acidic fire-adapted pine systems, they produce a much heavier fruit set post-fire in the landscape. So switching back to my home state of Minnesota, this study came out in 2016, and they took another look at those survey records in the bearing trees. And they created this map of our state looking at the prevalence of bearing trees, and also the bearing trees that are the areas that are bright red to yellow to light green would have been largely fire tolerant trees. That bottom southwest part of the state is white because it's prairie, so there weren't any trees growing in that section of the state. But there are some really interesting topographical features that influence those darker green areas, which were where there was pretty much fire was excluded. That large area in the top north part of the state is basically a former glacial lake and now a very large wetland complex. So fire would not be able to travel through that system. And then that really odd sort of dotted line section down in the south central part of the state, which is what we characterize as the big woods, and it's a closed canopy forest. There were significant rivers that were on both the north, western, and southern boundaries of that dotted area that were acting as fire breaks. So there's this oddball area that is not fire dependent simply because of the topographical features. And this study sort of broke it down further into looking at, well, what are these fire tolerant bearing trees, the pyrophilic trees, including deciduous trees such as the oaks, the hickories, hawthorn, and aspen. And then the evergreens species, many different species of pine that are also fire tolerant. And from a plant community standpoint, where I live in Minnesota, those sort of groups of different trees would represent systems such as oak savannas and oak woodlands, in addition to pine barrens. Now, the pyrophobic trees, the trees that are fire intolerant or mesophytic, include the maples, the alders, the birch, hackberry, and so on. And these deciduous trees in upland systems would have created closed canopy forests. And then some of those, such as the cottonwood and perhaps silver maple, would be dominant in a floodplain forest. And then the boreal trees, the evergreen trees that grow in boreal forests, including fir, cedar, spruce, and hemlock. So all fire intolerant trees. And what's really sent me down the rabbit hole lately is understanding better the importance and the rarity of these systems called oak savannas. And this is a map from the Tallgrass Restoration Handbook. The lighter gray area is showing areas of tallgrass prairie. And on that western boundary, of course, the Great Plains of the Midwest would have been shortgrass prairie, where there was less annual precipitation. And then the darker gray areas on that map are where tallgrass savanna and oak woodlands occurred. So you can see that, again, that tension zone in the middle of Minnesota with that dark gray and then the light gray in the prairie on the southwestern edge. But the tallgrass savannas were quite predominant through much of the middle and eastern and parts of the Great Lakes area. And the reason why I'm so interested in them is because they are so rare. So here in Minnesota, we had historically had 18 million acres of prairie. Now we have less than 1% of the original prairie remnants that remain. So that's a 99% decrease in acreage. But if you take a look at how rare these oak savannas are, historically 50 million acres occurred in the Midwest alone, and only 0.06% remain today. Where I live in the tension zone, we still have these large, iconic bur and white oak trees that are the remnants of this historic plant community. And oak savannas have been, are now globally endangered systems, particularly in temperate parts of North America. So they are so rare that people don't even know what they are or what they look like, because we lack these living examples to show the public. And savannas are not just a Midwestern phenomena. So this, I quickly kind of drew this together last week for this presentation, and I'm missing a lot of other examples of savannas, but I just want to get you thinking about that this is not just a Midwestern fire dependent system. There are California oak savannas, in the Southwest, juniper pinyon savannas. The Southeast is primarily all different types of pine savannas, and Deborah showed some nice examples of pine species in Maryland that are fire dependent. New Jersey pine barrens is a fire dependent system that is characterized as a barrens, which is just another word for savanna. And then you can see in the Northeast, at settlement, or at the first contact, because the Northeast has been inhabited for that much longer than the Midwest, you had predominantly oak and pine systems that were open and park-like and very likely fire-dependent systems. So the fire is really a system or a tool that has been influencing these systems for thousands of years post-glaciation. And the fire-tolerant trees have developed a number of traits that make them able to withstand fires, but sort of low intensity but frequent fires that run through the ground layer. And their leaf litter, in particular oak leaf litter, dries quickly, it curls, it's very thick, it forms air gaps. So it really creates this nice fuel that carries a fire through a system. The trees themselves have thick bark if they're fire tolerant. So once they reach a certain age of maybe 8 to 10 years old, they will not get killed back to the ground. They're able to withstand the heat of the fire because of their thick bark. But even if they're younger than that, they will burn back to the ground. But they have the ability to close their wounds quickly and then regenerate from the large taproots that they establish, rather than having a superficial root system. And we know how important oaks are thanks to the work of Doug Tallamy in his most recent book, The Nature of Oaks. And Doug has been highlighting the importance of keystone species, which are plant species that really many different organisms depend on within the food web. So they are critical parts of the foundation or glue, I would call, to glue that network together. And if you take a look at the keystone species plant list that Doug has developed with the National Wildlife Federation, you will note that many of those in the top 10, particularly for the woody plants, are fire-dependent species. And looking at keystone species from a pollinator perspective, many or the vast majority, I just looked at Minnesota as an example, but approximately 93% of the bee species that are pollen specialists rely on host plants that occur in fire-dependent systems. So for the most part, grasslands, but even on wetland edges that can be considered sometimes fire excluded, but also fire dependent. So these systems are much more functional because they're supporting a much higher diversity of species, including more keystone plant species. So if we want to sort of superficially define what these four things or plant communities within this prairie to forest continuum, we can think of prairies as it's a pretty easy plant community to describe. It is a grassland system. It has herbaceous ground cover comprised of grasses and sedges and flowering plants. It may have one tree per acre, but very, very few trees would occur in a prairie or meadow to consider calling it a prairie or meadow. Savanna, you start to get scattered populations of trees, sometimes groupings of trees, or sometimes single trees out in the landscape. And these would be tree species that are fire tolerant, including oak, some types of hickories, and of course pine. But you're still maintaining that very diverse prairie-like ground layer vegetation, which really helps to boost overall plant diversity. So not only do you have all the species that would occur in a prairie, but you may have some more woodland species that are thriving underneath the shade of some of those scattered populations of trees. And then when the tree cover gets a little more dense, anywhere from 50 to 70%, it's still considered a woodland. There's still patches of sunlight that are successfully reaching the forest, the woodland floor. It's still predominantly made up of fire tolerant trees because it's a fire tolerant system. And that may include, of course, oak, hickory, aspen, some of the smaller thicket-like plants such as hawthorn and plum. And then a forest is really anywhere from 70 to 100% canopy cover. So you're getting into more diverse number of tree species, but very, very shaded environment and very low herbaceous ground layer vegetation. And that's really what this spectrum is showing. So tree species diversities obviously increases from a prairie to a forest system. And in addition, so does tree canopy cover. But the reason I have that asterisk on the high on that bottom right in a forest is because these forests, if you're talking from a successional standpoint, when they reach this climax state, they tend to become very low in tree diversity. You have one or a handful of species that are dominating. This is an image of our big woods that I mentioned earlier, our closed canopy forest plant community. And it's dominated by sugar maple and maybe some American basswood. So what is going to happen if a sugar maple tree dies in this system? There are many sugar maple seedlings ready to take over. So they actually become less functional and very low in diversity when they reach this climax state. And looking at this from how do we really support more biodiversity and keep these systems functional? Well, we know that high plant diversity will yield high insect diversity, which really is forming the robust foundation of complex food webs. So with savanna and grassland systems, you're really sort of peaking at pollinator diversity as well as herbaceous diversity. So these are a noble system to be as a target for some types of ecological restorations. And again, these are more functional systems. So again, I like to get away from talking about forest succession. Savannas are a stable system, but they need human intervention and human stewardship. And they will succeed into a forest without that. But if we apply the right ecological restoration tools, such as fire and grazing, this system is a stable and functional system. Now, let's talk about carbon sequestration of all these sort of types of systems. And this is where we're thinking as ecological practitioners, how can we best plan for the future in the landscapes that we are planting and designing today? And when you look at carbon storage from the tons of carbon per hectare, this is a graphic from the IPCC. The visual capitalists made it into this sort of more pretty graphic that I'm borrowing from. But it really looks at basically the different systems throughout the world and their capacity to store carbon. So I'm highlighting the systems that are most appropriate for the people tuning into the presentation today. So including boreal forests, temperate grasslands, and wetlands. And switching back quickly to my home state of Minnesota, our Center for Forest Ecology at the University of Minnesota, they've done some pretty interesting modeling of the future trends of our state and how we are going to trend likely hotter and drier rather than hotter and wetter. And so this is the scenario with a +8 degree centigrade warming. You can see the red area is prairie. So that prairie is pushing from the west and southwest into basically the more than half of our state. So it's going to become a grassland dominated system. The light yellow is that transition zone. This scenario pushes the boreal forest that currently occurs on the north side of Lake Superior out of the state and into Canada. And then where broadleaf forests may persist is on that northern shore. And if we look at a 10 degree plus centigrade warming model, which is really where we're tracking right now, because we're not doing a very good job of mitigating the impacts of climate change, then our state really becomes predominantly prairie and hot and dry in a grassland system, again, sort of representing parts of Kansas. The last places that we will have a broadleaf forest will be on that upper eastern tip on the north side of Lake Superior. But this is the model I am looking at. I'm looking at sort of the worst case scenario when I'm thinking about how do we make these systems that we are restoring the most resilient for this climate change. So boreal forests, if we go back to the carbon sequestration capacity of these systems, that's out of the equation if I'm looking at it from the standpoint of Minnesota, and that's very likely from the state that you live in as well. And that really narrows it down to temperate forests, temperate grasslands, and wetlands. I'm not going to talk about wetlands, but because I'm focusing on upland habitat restoration, but looking at those two systems, the temperate forests and temperate grasslands, the really key thing on this illustration is where that carbon is being sequestered. So 153 tons of carbon per hectare annually stored in temperate forests, and 243 tons of carbon in fire-dependent grassland systems. But the big picture here is where that carbon is getting stored. And in forest, it's primarily in above ground vegetation, the woody plant material of trees and understory shrubs is storing that carbon. But that carbon storage is short-term storage, because when a tree dies in a forest, that carbon gets re-released back into the atmosphere. Whereas in grassland systems, most of that carbon is getting stored below ground in the soil, and ideally deep in the soil profile, where it will remain indefinitely as long as that soil is not disturbed. So these temperate grassland systems are much better at carbon sequestration than forests. And that begs the question, should we be planting trees everywhere for climate change in order to sequester carbon? And I would argue where grassland systems are appropriate, we should really be thinking about restoring land to grassland systems rather than keeping them in a sort of a primitive, low diversity, sort of not very functional system of a forest. And we've all seen various illustrations such as this. This is one by Janet Wissink. She prepared for Wild Ones. It's not really to scale, but most of you already know about the extensive root systems of both grassland and forward plants that occur in grassland systems. And the carbon sequestration is happening really with the dying off of about 1/3 of those root systems per year. And then that plant material is being deposited or kept within the soil profile. And that is how one way that these grassland systems are depositing carbon in the soil. And sometimes these grassland plants can have extensive root systems. And as Deborah pointed out, with natural disturbances such as fire or grazing, it will stimulate a lot more new root system growth that is again depositing more carbon into the soil. And then of course, the really amazing process called photosynthesis, where the plants are capturing energy from the sun. And they are basically pushing a lot of excess carbohydrates and sugars into the soil that they don't need. And that in turn is feeding biological things such as fungi and bacteria in the soil. The mycorrhizal fungi, we now know how important it is to help facilitate the nutrients and transfer nutrients from the soil to plants. So it's actually helping to feed this system that is really critical in order for plants to grow and for plants to thrive. And this is really important too if we are going to restore some of these more grassland systems. We have to keep in mind that tilling and chemical inputs and large-scale soil disturbance is really just going to re-release this carbon sink that we are creating. So I want to focus the rest of the presentation on sort of what I have learned over time about why our efforts, early efforts to try and remove invasive plants and restore systems was not working. And we weren't thinking of this from the standpoint that these systems were fire dependent, and that what has happened since fire exclusion. And for a lot of the landscapes where I live in that tension zone, we're at the tipping point from an ecological landscape management standpoint. And this tipping point is also called mesophication. And this was a term coined by Abrams and Nowacki in their seminal paper in 2008. They called it the demise of fire and mesophication of forests in the eastern US. And this graphic really shows what I've talked about earlier. You remove fire from the system, and what happens over time, 100, 200 years, is that these fire intolerant trees start to invade the system. And as they invade the system, the shading, cool conditions really erase any sort of grassland or diverse herbaceous ground layer vegetation. And then it becomes this sort of self or positive feedback loop where it's now a more moist and shaded condition, which facilitates the growth and reintroduction of more mesophytic trees. And at this point, which is where many of the oak dominated fire dependent landscapes in where I live here in Minnesota, this is where we're at. And this is the system and point in time that invasive species, including European buckthorn, which is our primary invasive plant in invading woodland fire dependent systems, garlic mustard, and then we are part of the glaciated part of North America. So any earthworms that occur here are non-native, and they are also wreaking havoc on the system. So this is also from Greg Nowaki's study, and I just want you to take a look at the top left graphic to start with. So what he's showing here is with fire, there's some troughs. So that ball rolls back and forth between being an oak savanna, oak woodland, or oak forest. And that is a stable system because there is fire is being used at various frequencies to roll that ball back and forth depending on how frequent the fire is applied. Now the upper right image, the left side is mesic, so more moist sort of situations, and the two right columns are xeric or very dry situations. And drier systems are even more stable and less susceptible to the encroachment of fire intolerant trees simply because of the conditions. They don't thrive in really dry conditions. So it's much easier to keep a dry site stable with the addition of fire. So taking a look at the bottom graphics, we are at the tipping point here in a lot of our systems. So we've had fire exclusion, those systems become unstable. And then as Greg Nowaki sort of coined the term, the ball drops down into the abyss. So if you are Sisyphus, which I think I felt like I've been Sisyphus for the first 10 years doing landscape restoration, we're trying to push this ball up a cliff that we can't get that ball over the top and back into a stable system because we haven't been applying the critical tool, which is fire. And they were just keep that positive or self-reinforcing loop just keeps traveling. That train keeps traveling down the tracks, and the system becomes more and more unstable, even if we try and, for example, take out the invasive plants from the system. So here is a picture of a typical landscape. This was formerly an oak savanna. You can still see large structured oak trees. That dark green plant that's dominating the understory is the European buckthorn. So this is an oak system that over time has had encroachment by fire intolerant trees, which has created more moist conditions. It has changed the system. The system has become unstable, and that really is just put out the welcome mat for these invasive species that have been introduced by Europeans. And so taking another look at an example, my orange markers here are marking oaks in what was once an open oak fire dependent system. And these oak trees are anywhere from 100 to 150 years old. They're slow growing. And that's one thing to keep in mind. These mesophytic fire intolerant trees tend to grow faster. And if you look at what's happening here, the blue markers are now marking the fire intolerant trees, in this case, American basswood for the most part in this picture. And now oaks have less light. They don't have the ability to regenerate. If an acorn falls on the ground, it simply doesn't have enough nutrients and light in order to germinate. So we have no oak establishment or regeneration once the system becomes unstable. And you can see the dark green plant, that's European buckthorn. And here's an example of where the management that has been applied to this system is simply to look at, I need to remove the invasive plants. And so the buckthorn has been cut once, and now it's starting to regrow, but you're not changing the systemic change in the conditions in order for it to become more stable again. So what is needed here is actually the harvesting, in addition to invasive plant removal, is the harvesting of the fire intolerant trees. I also want to mention that some of the other traits that mesophytic trees have to sort of keep the system more moist, and even though it may not be completely closed canopy. So we know that the understory is cooler because of those closed canopy conditions. We know that closed canopy forests are moister because they suppress fire. That light reduction also prevents a lot of evaporation, so the soil layer remains moister. And this really results in, again, low herbaceous diversity. Heather Alexander and colleagues published a study in 2021, and they looked at stem flow, which is not a new thing. Foresters have talked about stem flow for a long time, but she looked at how does stem flow influence the creation of this moist microhabitat. And this is when, like the picture I just showed before, when these mesophytic trees start to invade fire-dependent systems. And so many mesophytic trees like maples, beech, gums, as Deborah mentioned, for you, those of you in the East Coast, they have smooth bark. And so with rainfall, that water flows down the smooth bark. It doesn't get captured into a rough furrow bark that you would think of an oak tree. And it basically creates this moist microhabitat around the ground of the tree. So even if there's been encroachment of fire intolerant trees into a fire intolerant system, you try and run a fire through there, and the tree is creating these conditions to help prevent it from getting killed by creating this moist microhabitat. And the leaf litter, Deborah also talked about this, but oak leaves and fire tolerant trees tend to have thicker leaves. They hold on to the tree longer. They dry and curl quickly, forming these nice air gaps, whereas maple and other mesophytic tree leaf litter tends to be thinner, it's flat, it holds moisture, it mats to the ground, it doesn't have many air pockets. So it's not a good facilitator of carrying a fire through a system. And here in Minnesota, where we have invasive earthworms just devour mesophytic leaf litter first, and then switch over to the less palatable oak leaves later. So they're really creating bare soil conditions in these closed canopy forests, removing that insulating layer for the few herbaceous species that still are trying to exist in that system, and resulting in even lower diversity. So what can we do? Well, we need to sort of look at these landscapes through a different lens, whether you want to reintroduce fire, and the composition of these forests or woodlands, and maybe look at it from the standpoint of what is not quite right about this system, and is this structure and composition really influencing invasive species encroachment. So we want to get away from promoting these cool, moist, shaded conditions, which will, if you have an oak ecosystem, and oaks are extremely important as a keystone species, we don't want to do things that lead to the further decline of these keystone species. And with the warming climate, even if you're trending warmer and moister, looking at these keystone species that are fire dependent that are going to survive in the new normal where you live. So here I'm on a mission to preserve, restore, and reconstruct grasslands and fire dependent systems, because that seems like an appropriate model given our climate change modeling. We want to arrest that mesophication process if we're on the ground practitioners, thinking about harvesting some of those mesophytic trees, reestablishing fire into the system, removing invasive plants. That's just one step. If we just do that again, we're not going to change the systemic problems, and revegetating with that to reestablish that herbaceous ground layer vegetation. As Julie mentioned, one of my most recent projects is through a friend's nonprofit board that I serve on. This is a property that 32-acre property my municipality recently acquired. We formed the Friends group to help write grants and start the process of restoring the site. This is a 250-year-old white oak tree, and you can see this is what mature buckthorn looks like. It gets extremely big, 20-25 feet tall, and that oak tree is essentially suffocating from years of lack of land stewardship and encroachment by mesophytic trees in addition to invasive species. So the grants, we wrote a couple of grants, our Friends group, and were awarded about $90,000. And this is one of the really cool tools that we're using here in the Midwest to return some of these degraded systems to more fire dependent and open systems. So this is actually a forestry timber harvesting machine called a Feller Buncher. It's got a large spinning carbide blade on the front and grapples. And the drivers are so skilled. They are truly restoration people, not just someone driving a big machine. They understand and can identify different tree species. And they work through the landscape on frozen ground in the winter, and through precision surgery, cut out all of the invasive plants, in addition to harvesting some of those mesophytic trees. So we embarked on this starting last year, or I guess 12 months ago was when this harvesting happened. And then this was a drone shot view post-harvesting. You can see the iconic oak trees that we have left in the system. This spring, we were hoping for a fire because we wanted a low intensity fire to carry through the system, or excuse me, last fall. But we had a severe drought, which limited our burn window. So our burn will happen this spring. And burning will help sort of burn off some of the seedlings of the invasive plants. This is what it looked like midsummer. So we got a really nice response in sedge and ground layer species. We have established 17 different permanent vegetation plots to track the change in vegetation composition and diversity over time. We have conducted pre and post bird surveys. Likely be initiating some pollinator surveys here. So next steps are burning this spring, and then we take advantage of that temporarily burnt ground to broadcast both prairie and savanna seed mixes across the landscape. So with the long-term goal of revegetating this system, reestablishing the ground layer herbaceous vegetation, and that in turn will help carry and fuel future fires that we will have with regular frequency. So as my message as ecological land stewards is this: I think we need to start communicating the profound influence that Native Americans and First Nations people had, and the role of land stewardship. There's no longer this idea of pristine wilderness that humans never went into. Land has always been stewarded by people, and very thoughtfully. And thank you to ELA for having speakers from the Native American community. I think it's an excellent example of how we need to prioritize forging more partnerships to better understand both the historical and current land stewardship knowledge and practices. And then we also need to find opportunities such as this and in our conversations to initiate inclusion, understanding, and reconciliation. So I'm going to leave you with two quotes. The one on the left is from the Southeastern Grassland Initiative. Dwayne Estes is heading up that, restoring grassland systems in the Southeast. And the other is from a Midwestern restoration ecologist that specializes in savanna restoration. And I'll read the
Thank
myth.
Yeah, Heather, do you want to go ahead and read them?
Yeah, I'll read the myth of the forest first. So the current wooded state of many abandoned lands creates an impression of forest, but the forest perception is dangerously incorrect and has facilitated a century of mismanagement. And Dwayne Estes and colleagues say, this is from the Southeast, our society is in love with forests, but our desire to have a forested landscape is killing our native diversity, and we have been in ecological collapse for decades. There are thousands of acres locked up in state forests, state parks, wildlife management areas, nature preserves, and national parks that are silently trying to tell us that they are suffering. So thank you so much. Julie, I'll jump out of my slide here.
Okay.
Hopefully we didn't go over time, but I will
didn't-
also be available
Yeah.
in the garden room. So.
Excellent. Thank you, Heather. That was amazing. What a case for systems thinking. I just kept thinking, I just really appreciated how you laid it out and you focused so much on the history and the land management approaches and looking at it from such a holistic view and bringing people back into the system, counting that as a valid piece that was really wonderful. We do have some questions. We are kind of pushing the limit on time. I just want to ask quickly, someone wanted to know about your modeling. What tools do you use to model your ecoregion to project the future climate change? Maybe you could answer that quickly.
Yeah, that was based on our Center for Forest Ecology modeling. So I'm really just tracking what, our local ecological universities are saying. With that, then I'm extrapolating, okay, what does that mean from a plant community level? And really we're on this trend of hotter and drier here where I live. So it makes sense to look south and west from where I currently live. But yeah, I'm relying on other experts to sort of keep up with those modeling trends.
Okay. So we do have a number of other questions, but what I'd like to do is let's all move into the speaker garden at that time, and then we'll list the questions there so they're captured and they'll be there for you, Heather.
Great.
But thank you again so much. That was really wonderful. We are going to hear from Priya Nanjappa. Works with the national parks, and she works with the national parks and is inspired by her father, who would drive her and her brother around the country to see the same park she cares for today. I love that. She arrived at the National Parks Conservation Association with over 20 years experience in the conservation and science policy. Prior to NPCA, Priya served as commissioner specializing in wildlife, environment, and reclamation for the Colorado Oil and Gas Conservation Commission, who was appointed by Governor Polis for its inaugural full-time commission. And before that, she was director of operations for a nonprofit organization, Conservation Science Partners, or CSP, and was a program manager for the Association of Fish and Wildlife Agencies, where she also served as a national coordinator for partners in amphibian and reptile conservation. Park. She has twice been a mentor for the David H. Smith Postdoctorate Conservation Fellowship Program, and in 2019, Priya was the recipient of the Park Visionary Leader Award, the first woman and second person of color to receive this award. Priya is passionate about inclusivity and equity and diversity, and has applied these in her recent positions where she was able to influence and create beneficial changes in policies and practices. She recently served as a mentor in the inaugural cohort of Next 100 Colorado, designed to help connect Colorado's emerging and seasoned leaders of color through a series of partnerships, network formations, and leadership building. She also really loves toads. Outside of work, you can find her looking for them or just hiking and camping, often with her daughter, who shares her love of the outdoors. Please welcome me and join me in welcoming Priya. Yay! That's your round of applause.
Thank you so much. I really appreciate the introduction, and I just want to thank all the organizers and the sponsors for putting on this great conference and for thinking of me as a speaker. I'm really excited to be here. So thank you so much again. My name is Priya Nanjapa, and as noted, I work now for the National Parks Conservation Association. I'm the Vice President of Conservation Programs. And so in my department, I oversee our wildlife program, our water, clean air, energy, landscape conservation, conservation science, and also sustainability efforts. So it's a lot of great work that goes on at the National Parks Conservation Association in support of our great national parks and monuments, and really excited to tell you a little bit more about how I came into a career of advocacy. And I'm going to share my screen one moment. Let's see. Okay, I think hopefully I'm going to put it into presentation mode in a second, but hopefully you can see this. You can see also at the bottom, as noted, I am a toad lover. There will be a few toads in this presentation. My handle on Twitter is totally Priya. I must say I'm not as active on there as I used to be at one point in time, but you can find me there, and I do post every now and then. But what I wanted to just tell you about today a little bit was my background is in wildlife biology, and I'll talk a little bit about sort of my path, which was somewhat winding, as you may have noted just from the bio that as was read. But I started out in wildlife conservation, but where I am now is more in policy advocacy. And so hopefully I can give you a little bit of a sense of what that's like, go from a career that's mostly science-based, or even as a layperson, and how you can get more engaged in policy advocacy and some of the lessons that I've learned along the way in my 20+ year career now. So with that, I will continue. So much like this turtle on a fence post, it's really kind of a long story how I got here. And I didn't get here by myself. It was with a lot of partnerships and with a lot of people that contributed to the work that I was involved in, and that's really important. And I also just want to acknowledge, I am actually speaking to you all from what is now known as Denver, Colorado, which is the unceded lands of the Arapaho, Ute, Lakota, and Cheyenne peoples. And similar to this turtle, they were not moved willingly from these lands. And it's important for us to acknowledge kind of where we are as we think about landscape conservation, the history, the full and true history of the lands. And that's something that I really try to think about in the work that I do. But for me, coming into conservation really started in my backyard. I grew up in Iowa, and in my backyard, there was always a family of nesting cardinals, and I got to watch them, nesting in my family's tree. And as we would travel across the state, I would often see these red-winged blackbirds as well. And I noticed, how sometimes that beautiful red patch would show and other times it wouldn't. And it just, made me curious and interested. And I just kind of watched, the behavior. But in general, I was just kind of a fan of animals and of wildlife, and loved to be outside, loved to watch and just kind of observe as I was going through kind of just my day-to-day activities. I grew up in a time where I got to be outside most of the time during good weather, and in the summers, I was just be out until the sun set, and got to come back inside, when I heard my mom yelling, or sometimes if the porch lights were flashed. So I was one of those kids. And, I feel really lucky that I got to be, part of that generation where we got to kind of roam free, because that really probably led me in a lot of ways to the career that I have today. So along the way, when I was about 14 years old, I developed friendship with still a good friend of mine today, Emily, who's pictured here. When we were 14, we became friends, and her dad was a really avid bird watcher. So she asked me one day if I wanted to go bird watching with her and her dad. And I had never really done that before, never had done that before. My family was not outdoorsy whatsoever. They like to admire the things, from inside the house. And when we would go to national parks, as mentioned in my bio, we would drive through, go to the scenic overlook, maybe snap a photo or two, and then get back in the car and keep driving. So it wasn't until much later in life that I really figured out ways to spend more time outdoors. But this experience with Emily and her father was really life-changing for me. He had found the nest of a great horned owl in a tree, in a big knothole in a tree. And he took us there, and we waited for a while because he had seen the mother owl coming back in, around this time at night, at dusk, and after, hunting. And we were just waiting for her to return. And so we're sitting in this field, and the house that I grew up in was relatively noisy. There were phone calls, there were just, I don't know, loud conversations in general amongst the family. My mom was like cooking the curry for the evening dinner, and so there'd be onions, sauteing in the pan, and it was just loud, So here I was sitting out there in the field with the winds blowing through the grasses and the leaves, and you could hear, birds chirping and insects buzzing all around. And there was something about that was just really calming for me. And so even though it was sort of noisy in a very different way, it was an interesting noise. It was a fascinating noise, and it really just kind of captivated me. And then after what seemed like quite a while, it probably wasn't all that long, in came Mama Owl. And as she came towards the knothole, all the little chicks kind of came forward into the front of the knothole with their little floofy heads. And I was just in awe immediately. And we just, put our binoculars up and just watched and observed. And truly, I can say that in that moment, it's still such a vivid memory for me more than 30 years later, because I was, it was just made such an impression on me. And in that moment, I decided I needed to have some sort of career where I could work outside and work with animals. So that's kind of how my career began. And I really credit it to Emily. This picture was taken just a few years ago, and we were out bird watching again. And so, again, as noted, I love toads. I befriended a toad in my mom's garden as I was growing up. This little toad would hop around and eat the bugs, and I just kind of would observe it, and it'd come back every year. I'd like to think it was the same toad. It probably wasn't necessarily the same toad, but at some point I built a little half pot, a pot half buried in the dirt of the garden, so that the toad had a little place to go sit and hang out. And I just love toads. They just have these charismatic faces, these frowns, these kind of grumpy looks, these big eyes, what's not to love? And so I've now transmitted this love to the next generation. This is my daughter a few years ago, with the first big fat toad that she found. We were very excited to find this together and capture this moment. And the love affair still continues. This was just last summer. We went out looking for toads again, and here she is with one of the nice toads that she found, and she just really loved them as well. But where I really learned about the ecology and the conservation needs of amphibians and reptiles was at a field lab in Northwest Iowa. So where I started my career, my father was an engineer. He's an immigrant. Both my parents are immigrants from India. They both didn't understand why I was so drawn to the outdoors. They didn't know why I wanted to be outside and why I wanted to be around animals. So I started my undergrad career actually in pre-engineering, driven by my father, to kind of push towards that. And he was like, maybe you could start out in environmental engineering. So I thought, I would try that, but after a year of calc-based physics and analytical chemistry and linear algebra, I was pretty much fried. And I was filling all of my electives with general biology, with ecology, with botany, any courses I could find. And I eventually transferred to Iowa State University which was a larger field school and had a really great animal ecology and wildlife and fisheries program. And it was there that I stumbled upon this flyer. Even my biology advisor didn't really understand about, sort of wildlife careers. He was much more of a lab kind of guy. And I just happened to find this flyer. I asked him about it. He didn't really know much about it. And so I just looked into it myself. And I ended up spending a summer taking immersive field courses in plant ecology and taxonomy, as well as vertebrate ecology and evolution. And what turned out to be my master's professor taught that vertebrate ecology and evolution course, and he happened to be somebody who really loved amphibians and reptiles. And so a lot of the places we went, you would see a lot of these critters, as well as the birds, as well as the small mammals. So I learned about a lot of different things, but really kind of learned about the ecologies of amphibians and reptiles in that field experience. And and I started to really just kind of explore further, what are the careers in this field? And there weren't too many people that I was encountering at that time that really understood them. And at some point along the way, we had a presentation from somebody from US Geological Survey, and they were talking about amphibian declines. This was a phenomenon that was happening in the mid-90s. And I was, in undergrad at that time, and there were amphibians that were found with malformed limbs, and they were trying to figure out what was happening. And this was happening in the Midwest, in Minnesota, not far from where I lived and where I grew up, and where this field lab was. And so my professor was kind of getting involved in that work. Eventually then, in 1999, this program, the Amphibian Research and Monitoring Initiative, or ARMI, was started. And we were kind of doing some collaborative work with these folks. And so then I started to learn about the jobs in research, in amphibian research. I had explored a little bit further about some of the jobs with US Fish and Wildlife Service and the Park Service and other places, and was just trying to understand, what the opportunities that were out there. But really just kind of researching on my own. But I was very fortunate that in that time, because of all of those things that were happening, there were jobs available in amphibian conservation with that ARMI program. And so this is me in the field many years ago, surveying for spotted salamander egg masses. That's one in my hand. And we also were looking for wood frog egg masses, and that was kind of helping us determine the presence of these animals and get a sense of population status in the area. And this was in Maryland. I had worked for many years at the Patuxent Wildlife Research Center in Maryland. And through that work, I got engaged in the Northeast region of Partners in Amphibian and Reptile Conservation. And a few years into my term position with US Geological Survey, it was term limited and there wasn't an opportunity to extend it. This group, Partners in Amphibian and Reptile Conservation, was hiring for a state agencies coordinator. So I put in for the position, and I was fortunate enough to get it. And what I learned along the way is that putting the animals first, or the goal first, or the effort that you're trying to put forth to conserve the land, conserve the animals, what really works best is to not put yourself in the middle of it. Of course, we all want to be recognized for our work. Of course, we all want to do good things for the critters, for the land, for the plants. But if you don't make it about you and you make it about those things, you can really get a lot further, a lot faster. You can make a lot stronger relationships, partnerships. You can understand the needs of the critters, the needs of the people who are working with the critters, the needs of the policymakers. And you can really understand, what works and what is needed. And that's a better way that you can move forward. And I'll talk further about that. So as I was, oops, I think I'm going the wrong direction. Sorry. So in thinking about the animals and putting them first, you really start to understand, what is it that is needed? A lot of times, the first exposure to some of these critters is, it can be frightening. Maybe they just don't know about them. They don't understand, what their needs are, what their ecological niches that they occupy, what preferences they have for habitat. And the same thing goes in general for land conservation, for plants, for the native habitat. You really you know, have to understand those things. So here's my daughter, you know, back then, she was pretty unsure about that snake, but a few years later, here she is again. She loves her snakes as well. She's very savvy about, you know, which ones are okay to pick up and which ones are not. And I still have to kind of encourage her to, you know, still be judicious around her friends who are still kind of learning. But, you know, once you kind of can help people understand what those issues are, what the needs are, and to learn to appreciate, you know, what the particular thing is that you love, that you want to try to communicate to other people, including policymakers, you can really get them on board. And so with my career with Partners in Amphibian and Reptile Conservation, that position as the state agencies coordinator got adopted by the Association of Fish and Wildlife Agencies, which is based in Washington, D.C. You can see the Capitol there behind my head. And so I got to work in the middle of it all. You know, the Association of Fish and Wildlife Agencies is a membership entity, a 501c6 for those of you that know kind of these things. So it's a nonprofit, but it is one that is membership based, and all of the state fish and wildlife agencies all across the country, you know, from the Maryland DNR to the Colorado Parks and Wildlife Division to the Washington Department of Fish and Wildlife, you know, in all across the country, we're all members of this association. There's also members that are engaged through Mexico and Canada and the various provincial and territorial agencies there, as well as the federal agencies that are kind of have a different membership in there. And so we got to work with a lot of those folks. And the way that the Association of Fish and Wildlife Agencies got work done was through a bunch of these standing committees. So here's just a smattering of some of the committees that were already in place when I came on board. And one of the things that I was able to accomplish while I was there was to create an amphibian and reptile committee. And what's important about this is that at the end of these meetings twice a year that all of these state fish and wildlife folks in leadership would come to, they would have action items that would be discussed around a big table of all of the different agencies that were represented. And you could bring forward issues and needs, and sometimes there would be a vote about, you know, certain actions that might be taken. And so I was able to create this committee and bring it forward and get approval for it. And so then we were able to bring amphibian and reptile issues in front of this this governing body of the Association of Fish and Wildlife Agencies. And so it was an opportunity to finally raise the profile of these low profile critters, both literally and figuratively, and to be able to talk about their policy needs. And so a lot of this was state level policy, but some of it was also federal policy. And one of the things in working with state herpetologists, so herpetology is a study of amphibians and reptiles, and you might hear me use the short term herps, that's referring to amphibians and reptiles. We found that one of the biggest issues was unregulated collection of amphibians and reptiles. So I'll talk a little bit more about this, but how we manage wildlife differs quite a bit in different types of groups of animals. Amphibians and reptiles were largely unregulated at the time. They still are to a certain extent compared to our game animals, and I'll talk more about that. But I was able to partner with the state herpetologists and biologists, with law enforcement in the states, you know, the conservation law enforcement folks, and those that were in the lead of the non-game or the sort of wildlife divisions, and be able to work with them to understand what it was exactly that they needed. We created this summary document that is, the cover is shown here, that summarized what the regulations were for collecting animals for personal use, you know, whether it was a pet for your child or for exhibit purposes, or whether it was for scientific collection. A lot of great research that happens, you know, requires a scientific permit and from the state, or commercial collection. And so commercial sale of wild animals is still allowed in many states in different forms, but you sometimes needed a permit. And what I learned in creating this report, along with the partnership of all of these state herpetologists and biologists all over the country, was that it varied quite a bit, you know, all across the state. And so I started to think, well, how am I going to reach the leadership? So those were the non-game biologists, the state herpetologists and wildlife biologists, who were working with these critters, who kind of understood these issues. But by and large, the leadership in these agencies are people who were coming into those agencies primarily from the game side of the world, from deer, from bear, from fish, you know. And so I had to first understand what it was that they valued. And that was going to be the way that I could approach them. So this quote, apparently it actually comes from a slightly different quote from St. Francis of Assisi, and was modified perhaps by Stephen Covey, who wrote The 7 Habits of Highly Effective People. But it's a great quote. You know, first try to understand where other folks are coming from, and then you can better understand the way that you will be understood. And so in general with conservation policy, what I also learned is that in changing or adding new conservation policy, it really takes perseverance. It's a very long process of building these relationships, of convincing people, of working with them to try to understand, you know, the issues and the needs. It takes a lot of people. And, you know, I'm really proud of all the partnerships that I was able to build in this time and trying to, you know, help convince people what was needed. But also those people pulled a lot of weight. They gave me the information on what was happening in their own state. There were a lot of researchers, academic researchers that were providing data. You know, it takes a lot of time and effort and man hours, people hours. And it takes passion. You know, you have to be really engaged in the issue, but it also involves compassion. And that's, again, kind of understanding where other people are coming from. So again, you know, in thinking about these needs for the policy to better regulate this commercial sale of amphibians and reptiles, and even some of the personal collection in some of these cases, what I found that was really resonating among all of the state leadership was this North American model for wildlife conservation. This is the basic underlying concept under our modern wildlife management today. It's the idea of game licenses or hunting licenses in order to remove a wild deer or to remove a wild fish. You have to have a permit for that purpose. And that allows for tracking, it allows for setting of limits and all of those other things. But that didn't exist for amphibians and reptiles. And there's other critters that the same thing applies to. There's plants, you know, it's the same sort of idea. But what I learned is this could be applied more broadly to other non-game wildlife like amphibians and reptiles, especially because there was a community that was using these critters. So there was the use for food. There's still a lot of subsistence use of turtles and frogs. There was a commercial use, as I mentioned, and a lot of that was still unregulated. There is a use for skins, you know, alligator skins, snake skins, things like that. And so there was a real opportunity to apply this model, and more than anything, to appeal to the leadership of these agencies by saying, you know, you are managing the use of your deer, your bear, your elk, et cetera, in these ways that you can really track and understand what's happening to them. But we don't have a good sense of what's happening to these amphibians and these reptiles. And so therefore, how are we able to truly manage for them? And that was still part of that is the charge of the state Fish and Wildlife agencies, is to manage for all of these wildlife species. So along the way, a colleague stumbled upon this figure, and I thought, what a great way to visualize why there is a challenge for amphibians and reptiles. And in particular, we were focusing on turtles, because turtles, you know, I've said before, if you've heard the term, the tragedy of the commons, you know, this is what happened in the early 1800s, 1900s, when overhunting became a thing. You know, we were almost out of deer, which is crazy to think about in the Northeast with white-tailed deer. You know, they're everywhere. They're kind of a pest now. Canada geese, you know, same thing. They're everywhere. But these populations had really dwindled to a time, and a lot of that was because of the commercial trade in these critters, you know, understanding kind of what was actually going out of the wild system. But along with that, you have to understand their life history. So if you've been looking at this chart as I'm talking, what you're really seeing here, and hopefully you can see my cursor, we've got a snapping turtle on the left side, we've got bear, moose, and deer in these different columns. And in the time that it takes a snapping turtle to finally get to sexual maturity where they can lay a clutch of eggs, a bear has reproduced itself over 25 times. In other words, there's been at least 25 generations. It may only be a couple of bear each generation, but it's reproduced itself that many times over. In that same time frame for moose, you will have had 681 moose that in that same time frame of it's about 17 years that a snapping turtle reaches sexual maturity. So you could have produced that many more moose and over 900 deer. And so you can kind of think about this in terms of wildlife management. This is how these managers are thinking about setting limits and things like that. So, you can remove quite a few moose and quite a few deer from the system, and the system can still continue reproducing itself. You can still have a lot of animals in the system, even if you're removing them. And so you have these permits that you allow for the removal of these deer or the bear or the whatever. But with a snapping turtle, a lot of people will say, oh, they seem so abundant, but what you might be seeing are the large adults. You may not be seeing how many young turtles are coming into the system. And because they take so long to mature, because they're very secretive, same is true for a lot of reptiles and amphibians as well. You don't really know for sure unless you're actually monitoring. And so that really resonated with a lot of folks in kind of describing why we had to have a better sense of regulation for these critters. So what I was able to do, again, along with a ton of partners, a lot of people that were involved in this, was create a set of recommendations of applying that North American model of wildlife conservation to herpetofauna, or amphibians and reptiles. And we introduced this back in 2014. And what I learned in that process was my next insight, which is emotional intelligence. What I mean by that is that sometimes people are going to react to you in ways that have absolutely nothing to do with what you're talking about or who you are or what you're saying or how you're saying it, but it sure feels like that in the moment. They're reacting like what you're saying is crazy, you don't know what you're talking about, you're attacking their way of thinking or their way of managing. And those were some of the comments I was getting as I was introducing this initially amongst these leadership in the States. And what I learned, from that was more about them. There was something that they were feeling that was threatening, or maybe they were just having a bad day. But that's what I've learned as I've approached other people in leadership and agencies, politicians, is that sometimes the way they react has absolutely nothing to do with you. And you have to be able to just kind of, hold your ground and just listen, or maybe just decide, okay, well, thank you for your time. I'll come back another day. So those are the types of things that are really important in political advocacy. And so I share that with you here. Along with that comes with this idea of getting comfortable with being uncomfortable. When you are advocating for policy, sometimes you're going to have these uncomfortable conversations because you often are going to have to talk to people that may not necessarily be on the same page with you or may not be there right at that moment. And it is really important to be okay with that discomfort. People can get very anxious. I know I definitely would get more anxious. I would get uncomfortable. And when, sometimes certain people, especially politicians, they sense that anxiety, that discomfort, that weakness, for lack of a better word, and then they will start kind of throwing other things at you, and you kind of can get really thrown off. So if you can learn in advance that you might be uncomfortable, you might need to be prepared for tough questions or different questions, and you can just kind of stay on your message and say, I'm not really talking about that. I'm talking about this. What we really need to do is focus on this. That's the kind of thing that will get you where you're going. So in general, with growth comes discomfort, right? You've always heard of growing pains. This is a true fact in any sort of aspect of growing professionally, personally, and even in doing things like political advocacy. So sticking with this theme, sometimes your partners are not your friends. And I don't know how well you can see this image here, but right here is a rattlesnake. So you can probably see that rattlesnake tail, and there's a rattlesnake in a burrow here, but sitting on top of that rattlesnake is a woodhouse's toad. A friend and I found this, saw this here in Colorado and took this picture. But probably what we think was happening there is that toad was using the snake for warmth. Maybe the snake had been out basking, and the toad maybe was already in the burrow or came into the burrow, and the snake was nice and warm, so just sat on that snake. But obviously these are not critters that hang out together on a regular basis, as far as we know. And so sometimes to accomplish the thing you need to accomplish, you have to approach the people that you don't share the same philosophies with, that you don't agree with. Maybe they've taken a stance on something else that you're completely opposed to, but you still have to engage them. And so that's where, again, the emotional intelligence, the being comfortable with being uncomfortable comes into play. And so sometimes as well, the people that are your biggest hurdle to moving an action forward are also your biggest opportunity. So if you can figure out the strategy to engage with a person, maybe you find something that you have, that you learned that they took a stand on that you agree with. So you start there, you just kind of start talking with them, start building that rapport, that relationship, or in general, just talk to folks about the things that that they already care about. They're going to be more willing to learn more about what you care about once you kind of develop that relationship. So again, as I said before, perseverance is the key. But I really appreciate this quote. Sometimes that's the impediment. It's the impediment to the action that actually is going to be the way forward. And if you can figure out a way to move that barrier or break it down a little bit, then you might be able to move forward. And so in the example of applying the North American model to herpetofaunal conservation, there was one particular person, and he was in a leadership role when I was presenting this, in the group. And here I am. At that time, I was maybe in my, mid-30s or something, in front of a room of a lot of folks who were in their 50s or older, leaders of state agencies, had been in the field for many years. And I'm presenting this information, and this one leader who's very influential, he says, "I don't like this. You're challenging my way of management. You're telling me I'm doing a poor job." And of course, I wasn't saying any of that. I was just saying, hey, here's an idea, and here's some suggestions, and here's some recommendations. And again, this came from a whole bunch of other people. And I will say also in that moment, what was really interesting is nobody stood up with me to say to him, hey, let's think about this a little bit differently. What about this, or what about that? And so instead I said, is it something about the way we're saying things? Is it something about what we're saying? And he just said, I don't like it. So I was like, okay, fair enough. We'll rework this, or I'll talk to you separately and we'll come back. And so I did work with him directly, and I had a bunch of individual conversations along with some other people as well. And ultimately we were able to get this approved, and his approval was a key part of that. So again, the impediment to the action was the way forward, and I just had to be, I had to persevere, I had to be persistent. But we got that approved, and I have to say I'm really proud of this whole process, because a lot of states since that time have tightened their regulations on commercial collection. They've evaluated, kind of their population status, and kind of rethought about this quite a bit more. And so, all this time I was working with partners in amphibian and reptile conservation. I was part of our strategic planning process, and we updated our mission statement, which you can read here. But I just love this photo because, sometimes you're the gator and sometimes you're the turtle. Again, two animals that don't typically hang out. But, what they're really doing here is they're sharing the sunshine, and both of them can bask. They can work together to get what they need. So, those proactive partnerships are really a key part of political advocacy. And again, especially when you're approaching someone that you might not share those philosophies with, you're not really sure about, you can find that sliver of common ground. It might be the tiniest little bit that you share, that you agree with, and that you have in common. But that's the point at which you can start out, and you can find that path forward. you can start building that relationship. You can start building that trust. I had another colleague in Missouri that was trying to work with a private landowner, and it was related to snake conservation. And of course, snakes are very unpopular. It's really hard to find people, to be able to do anything, good for them, especially on their land because of fear and because of other things. But if they are, if you approach them and develop a relationship, and what this colleague of mine did was he just went over every day and brought coffee for this older gentleman landowner, and they would just sit on the porch. And they would just talk about, sports, or talk about the land, or talk about, the plants or the crops. And he did that over and over and over for months. And then finally, he was able to start talking about some of the other wildlife, things, some of the programs that were available that could help this guy, this private landowner, to be able to accomplish some of the wildlife conservation or the land conservation that would benefit the wildlife. And they were able to make progress. So it's finding that common ground. It's establishing that trust, that relationship, and that's a really important part. Uh-oh, my screen has frozen. What is happening? Uh-oh, okay, there we go. So also in that strategic planning process with Park, we updated our vision statement. And what I think is important here are the pieces in bold. And that is that we just wanted to work together with those who are making the decisions to consider these critters, these amphibians and reptiles, in their decision-making, in their land management actions. We had people in the same agency that were doing one action that was completely in opposition to the needs of the amphibians and reptiles. And in some cases, these were even imperiled species. And, it's helping them understand. And sometimes they just didn't know that. And then you just talk to them. But if you go at them, saying what you're doing is wrong and what you're doing is hurting these, these critters, and you're supposed to be a land manager, how, if you come at them, guns blazing, of course, you're not going to get a good response. So instead, you come together, you think about what you have in common, you think about where are the places that you can work together, and then you start your messaging based on that. And then you can maybe get them to at least consider it. And at least that's a starting point. Not that long ago, migratory birds, songbirds, were in demand for their feathers, for the fashion industry. And there was a lot of, meetings and regulations that went into place. And of course, the Migratory Bird Treaty Act, some of you may be familiar with, that was a huge thing because that was a federal law that was passed. But that got migratory birds considered at pretty much the same level now that deer and bear and fish are being considered. And we're getting a little closer with amphibians and reptiles. And I think that's really great with the partnerships that Park has really helped to establish. So one of the other examples I wanted to give you was with this disease of salamanders that was just described in 2013. And here's the paper that described this new disease called Batrachochytrium salamander vorans. And no, there won't be a quiz on this, but we call it BSAL for short. It's a new pathogen that is very similar to another chytrid fungus that you may have heard of, which is called Batrachochytrium dendrobatidis. And it was thought to only infect frogs, but also had some impact on certain salamander species. But this one in particular seemed to be really like a salamander specialist. We know now that it does actually impact certain frog species, but what was happening with this is this was a new pathogen, new to science. It was causing the demise of salamanders in parts of Europe to where the wild populations were almost like more than 90% extirpated, 96% wild mortality in the Netherlands. It was present in wild salamanders in Asia, in Vietnam and Thailand and Japan, but they had apparently evolved with it. And so they had become resistant to it. It was not causing mortality there. And so the question was, how did it come to the Netherlands? What was happening? We knew that it had been around for over 150 years in museum specimens. But what we also found that it was present in the commercial trade of some of these salamanders and also in some captive populations. So we figured out that BSAL was a threat because, especially to the United States, because a few years ago, over 100,000 salamanders were being annually imported into the United States. And they were primarily these Asian newt species, which are some of those that can harbor this B-Sal pathogen and not die. But we found that North American species were susceptible. So there was a big bunch of partners that started to come together and share information, share their research, and try to understand what they could do to stop the progression of this disease into the United States. And you know, when you think about the risk here in the United States, we have a lot of salamanders in the United States. You may not have known, but the United States is the global one of the global salamander hotspots. In fact, in the Carolinas and in the Appalachians, so here you can see here in North Carolina, Tennessee, Georgia, Virginia, are amongst the most speciose, or the most number of species of salamanders exist in those states. So when you see these numbers here, we're not talking about 60 individual salamanders, we're talking about 60 species of salamanders. So that's how many salamanders were potentially at risk. And so we needed to find out more information, which ones were at risk, you know, what were the biggest threats, how, you know, what could we do and how could we find out? But in order to do that, obviously you needed resources, you needed, you know, other protections. We needed to halt that trade coming into the United States. So what did I do? I went over to Senator Richard Burr's office. He's was a senator in North Carolina. He also was a head of the Appropriations Committee at the time. And so there was an opportunity to kind of, you know, talk to him and his staff about this issue and letting them know that, look, in your state, you have the most salamander species in the world. If these salamanders started to decline to the point where you needed an Endangered Species Act listing, the forestry industry in your state would be highly compromised. The development industry for developing homes and et cetera would be highly compromised. And so again, you know, finding like, what is that thing that they valued that they would need? This is a conservative Republican, you know, and, you know, there were positions that were probably not very favorable to wildlife that he had taken in the past. But it was important to come to him and to say, look, this is your state. These are your animals. These are your industries that are going to be at deep risk if we don't do something about this. And so staff from his offices, from some of those other states that I noted there, California is another state that has a lot of salamander species. We started talking to them, and that really catalyzed some efforts. They began talking to some of the federal agencies. In the meantime, we were also researching, you know, what the opportunities were, you know, but in all of this, you know, I had to approach some of these politicians that, again, you know, maybe hadn't taken, you know, strong stances on wildlife conservation in the past. And, you know, you just have to remember that, you know, not everybody is going to be perfect in their records. And so again, you know, you may have these differing philosophies, but you have to work on this together. And so with a lot of time and effort, we learned in particular that there weren't any policies on the books to prevent a pathogen coming in that was from wildlife and would only affect other wild animals. We do have policies currently that the CDC manages for a wild animal disease that can infect humans. And we've seen that, you know, with West Nile virus, with there's the potential, or there's always the potential risk with avian influenza. There's a swine flu, you know, a couple of other things like this that can start with a wild animal, but can move to human populations. So we have policies through the CDC and regulations that can occur that way. We have regulations within the U.S. Department of Agriculture that will prevent diseases of wild animals that would potentially affect agricultural animals. So again, avian influenza is a big one right now. You probably have been hearing, you know, it's affecting other wild animals, but it's also the reason that it's gotten so much attention is because it affects poultry. You know, it affects our farm populations. And so there's a particular pathogen that's carried through a tick on a tortoise that comes into the United States and is screened for because it can create an issue for livestock and for our cattle in this country. And so there are all these screening processes in place. There's controls. There's management for those tortoises that are coming into the United States. But what we learned is there's no policy at all for diseases of wildlife that get transmitted to wildlife. So some of you might be familiar with white nose fungus. This was the disease of bats that was killing a lot of bats in the Northeast in the beginning, and now has spread to many parts in the West. And what we learned was that there was a very similar pathogen in Europe. But again, even if we had known that at the time, by the time we were sort of discovering it, it was already spreading a bit too fast. But had there been a way to prevent the movement of animals somehow, or even the movement of people, or regulations for cavers to clean their boots or things like that, there wasn't any policy authority to be able to put those things in place because the risk was only from wildlife to wildlife. So we had to figure out a workaround. And what we learned was that the Lacey Act, which is a law that has been on the books for over 100 years now, it has a provision for injurious wildlife. And that is the idea of listing an animal that can be injurious, especially to agricultural interests, or to other interests in that we have, especially industries around. But it has been used more and more. There have been precedents for invasive species. So there was no way to stop this pathogen, B-Sal pathogen, or to screen animals for this pathogen. But what we could do was block the entry of the host animals by listing the host animals as injurious wildlife. So a lot of us worked on this. We talked about it. I ended up talking to folks in the aquaculture industry, in zoos and aquariums, and similar other disease issues in the past, especially involving amphibians, had been discussed with them. They were very against that because in those other instances, these were pathogens that were already found in the United States. And so the cat was kind of already out of the bag. They were like, you can't really stop this now, so it doesn't make sense for us to get on board with this. But in this instance, this B-Sal pathogen, there was a lot of research that was happening, monitoring that was happening, and we were not finding it yet in the United States, thank goodness. And so far, that's still the case. So we were able to block the entry of these salamanders with support of the aquaculture industry, with support of the pet industry, with support of the zoos and aquariums. And it was only because of all of these partners that typically, haven't always worked together, that we were able to influence the Fish and Wildlife Service to work more quickly and to put this rule into place. So in 2016, they released this listing of several hundred salamander species, especially those that were heavily in trade. And we'd like to think that is part of the reason that it still has not been detected in this country. And I wasn't expecting this, had no idea it was going to happen, but they cite me in the rule as somebody that they spoke to, for why we needed to, include certain species in this rulemaking. And I'm, again, just really proud. It was not about me, but in doing that, in bringing all these people together, in talking to them and sharing information, they noticed, and I'm just super humbled and grateful. Truly had no intention of, anything related to me being part of that. I just wanted to see this disease not come into the country and not take out a lot of our great salamander species that we have here. For those of you in the Northeast that might be familiar with your amphibians, red spotted newts, the little red F's you might see sometimes walking around in the rain in the woods. Those are a very highly susceptible species. And so, can you just imagine if you wouldn't see those out wandering around? That was one of the things that was really driving me, forward with this. But along with that, with some of this policy work that I was doing, I got invited to speak in a tri-national convention with Mexico, Canada, and the United States about turtle trade and about turtle regulation policy. And so, working in all these sort of policy and knowing some of these levers that you could pull or what the opportunities are to potentially influence policy, got me invited to this meeting. And that's led to some additional protections for some of the turtles that are in trade. And then it's also led to a lot of really fun stuff. These are some of the podcasts that I've been able to be a part of, or other interviews that I've gotten to do, or presentations like this. And now I'm really happy I can add the Ecological Landscape Alliance to my list of groups that have found me along the way and have invited me. I'm just really honored to, be able to share in some of these things that I've learned. And as mentioned in the intro, I was given the 2019 Visionary Leader Award for Park. And that was just such a huge honor for me because again, I was just trying to create these policies and these structures for these critters, but it was getting recognized. And what one of my colleagues said in giving me the award was that I was a keystone species for park. And for those of you that know wildlife ecology, you know what a keystone species is, but if you don't know that, at least maybe you can recognize that the keystone is that central stone in the arch, like of a bridge or any arch structure. And that keystone is the one that's in the middle that's holding up the rest of the stones. But the way I like to think about it is if it wasn't for the rest of those stones, that keystone would just fall right into the water. So even though they were calling me the keystone, I couldn't have done it without the support of all of those other folks and all of the other partners. And, again, I think that's really cool that they, made that analogy. But, one thing that I've really tried to do in my career is think about the ways that I can bring others up. And the way that I think I have risen is by lifting other people up with me along the way, giving them opportunities. And I just encourage you all to think about the ways that you can mentor, that you can guide, that you can help convey the lessons that you're learning along the way, and lift up those, especially those who may not always get the same opportunities to learn in school, to go to the best schools, to get the field school opportunities, to do those kinds of things. One of the ways that came into play for me is when I was with the Association of Fish and Wildlife Agencies, I had an intern that was working with me on some of the regulations and collecting the information. And she came to work at the state of Colorado in the DNR. And so they were recruiting people for a wildlife habitat committee that was to be able to help determine how grants were distributed across the state. And she, in her policy role, was able to recommend to the head of the DNR to contact me and invite me to this position. So here is my intern who, rose into this great role. She got into a lot of the policy work after some of the work that we did. She then thought back about me and a way to bring me into another opportunity. And that led to me getting, recognized through the Department of Natural Resources and becoming an appointee through the governor for the Colorado Oil and Gas Conservation Commission in their wildlife and environment seat, which was a 2-year appointment. And it was a really incredible and huge learning experience. And I, hope I did some good for the wildlife and the environment here in Colorado. We were able to set some new rules. And so then I got to be a decision maker and apply kind of some of the things that I learned in advocacy towards the decision making. And now that's made me even a better advocate. Uh-oh, am I going backwards again? Oh, no, sorry. I lost my train of thought. So, again, just kind of remembering the ways that those common ground opportunities, those opportunities to bring others into the fold, to understand others, and then to be understood. This actually applies a lot in thinking about the ways that you can mentor people as well. You can bring them into the fold. You can think about the ways that people differ from you as being opportunities to learn from one another, to exchange ideas, to give them opportunities. And, I've gotten a lot involved in equity and diversity and inclusion, and I know I'm running out of time. And one of the ideas of inclusion is to, kind of integrate something in to a space that it was otherwise would have been excluded or marginalized. And what I learned in some of this policy, especially with amphibians and reptiles, is amphibians and reptiles are kind of an excluded or marginalized group in the wildlife world. So the policies that I was creating were policies and acts of inclusion. And a lot of our policy and advocacy work is that way as well. I'm going to skip through this a little bit, but, just the idea that equity is not the same as equality. You have to be able to think about the needs of different entities, but how they can all work together and how they can thrive. And we all may know a little bit about biodiversity and how the variety in an ecosystem, different structures, different habitat types, different animals, really creates a thriving ecosystem. And the same thing is true for diversity in general, diversity in the groups that we have, not just ethnic and racial diversity, but diversity in views of thought, in perspectives, in experiences, life experiences, economic backgrounds. You would be amazed the types of things, the types of insights that people can bring just from having a different way of growing up, a different way of living, a different experience, a different culture, how that can really contribute to the richness of your efforts and your work. So now with the National Parks Conservation Association, in the vice president role that I have, before I was really trying not to rock the boat, but now I'm in the lead and I'm steering the boat. That's my daughter there in the boat photo in front, kind of steering the boat. And I'm really hopeful that, with all of these ideas and insights, I'm learning about the ways that policy, that equity, that inclusion, they all sort of work together, and they're ideas and thoughts that are important to incorporate in your policy and advocacy efforts. And so I hope that was helpful for all of you. I know I'm a little bit over, but I don't know if there's time for questions, but would love to answer any.
That was wonderful, Priya. Thank you. That was so great. And also, I want to add good graphics. That's another one. We had really captivating slides and pictures, and it really, it illustrates the insight. So I definitely appreciated that. Let me just, since it's 5 o'clock or a little bit past, I'm just going to go through the housekeeping and say the end of the day thing, and then we can stick around for questions. So I'll take a minute, not even. So I just want to tell you all, you can stay with us in this room for questions after, but I wanted to thank you for attending these past 2 days. It's been really wonderful. We've really appreciated your participation. And to ask you to make sure you fill out the evaluations. You can go back to the main stage and you can see all the evaluation tabs for each of the presentations. So we really appreciate that feedback and we use that. So if you could take a moment to do that, we'd appreciate it. Also, thank you again to our sponsors. Shout out to Pleasant Run Nurseries, Understanding Ag, Soil Health Academy, Ernst Seeds, and the Tick Suit. So thank you very much for your support. And there is going on now until 5:30 in the networking rooms, the regional networking rooms. There's a happy hour. So feel free to go there and talk to some folks. Or stay here with us where we are going to talk a little bit more to Priya. All right. Okay, that's done. I just wanted to say that it was interesting. I've taught a little bit in college adjunct world, right? And so in the classroom versus outside of the classroom, totally different, right? Like people that were falling asleep in class, you bring them outside and all of a sudden they have a million questions. And so as you were talking, I was thinking about policy work and then field work and how, like boardrooms, agencies, committees versus being in the field and, finding toads. Like, how does that, I don't know, like, I feel like you are demonstrating that one definitely feeds the other, but I just maybe you want to mention that.
Yeah, no, I think that's true. I mean, it sort of goes along with what I was saying, I think just generally life experiences, can really contribute to, the richness of how you approach the next thing. And having that, field experience and kind of understanding some of those different ecosystem sort of components in the science side of things, and then moving into the policy world and, all the while kind of a lot of the work having to revolve around relationships and communication and messages, which I think is also kind of part of teaching as well, sort of figuring out what resonates and what you see, works with communicating and the message, actually landing with your audience. It's all relative. I think the one thing that was interesting for me though too is that as much as I loved being outdoors and being in the field, I was one of the few of my other colleagues who actually wanted to be around people more. And so I think a lot of field biologists, go into it because then they can kind of be apart from people and be on their own and work very independently. But I actually really loved, the opportunity once I got into the policy work to work with people.
That's great. That's great. And speaking of people, let me invite, if anyone would like to unmute themselves and join into the conversation, please feel free to do that. There was a great comment earlier, putting the work first, putting the animals first. That's a really good piece of advice. It opens so many doors when you kind of think about that first before your own. So loved that.
It's great.
Um,
Yeah, I think it was somewhat unintentional. And at the same time, I've really realized how that can be really beneficial in what I observe in, sometimes certain colleagues, sometimes some of, my own staff, is this real desire to be out front and show everybody what they can do. And you can do that by the work, by doing good work, by building good relationships. And I think, I think that's a really important piece of just leadership in general.
There was a question about the salamanders when you were talking about, you mentioned the trade. So
Yes.
Those are kind of big numbers. Why were so many imported to the US?
That's a great question. I think there was just a really big pet trade, and there weren't any regulations or limitations. So, and at the time there were no concerns, so nobody had a problem with it. A lot of these, animals are also coming from, developing countries. And so I think, those countries also didn't have much in the way of regulation or maybe even, wildlife policy. And certainly, the US is very different in the way we approach wildlife policy compared to other places. But I was shocked as well, to see that there's hundreds of thousands of salamanders, but you would actually be amazed. It is orders of magnitude higher when it comes to amphibians, to frogs, especially for live trade, for frog legs, and things like that. So it's sadly, I've learned that American bullfrogs are being farm raised in Asia and then imported back here. So yeah, that's a whole nother topic for another day. But yeah, it's still pretty massive.
Hi, Priya. It was really great listening to you. I'm out in Brooklyn, New York, and so we have a botanical garden and an animal rehabber, and we have a turtle sanctuary. And I think it's the only one in the New York area, anything near. So, we're showing kids native turtles, and it's like I'm showing them something from another planet. They've never ever seen them. Right. So we're just, we're really in our infancy, and we have this program, but I'd love to reach out for you for any help that you could have. We have box turtles, we have a couple of the native species, but we want more, and we really want to advance our sanctuary so that it's, more interesting with this, with the different things. And I want to try to introduce, yesterday they had a whole great thing on vernal ponds. You know what they are. So we had a whole talk on that yesterday. This guy was brilliant. And I have a vernal pond, but I want to put more into that, talk about how important they are with toads and amphibians. And also, the spadefoot toad is native to the Brooklyn area. It's pretty dry here, and I think the spadefoot toad can take that. So so anyway, if you don't mind me reaching out to you maybe for more information on some of this stuff. And yesterday, I'm an animal rehabber, and yesterday we were just quickly this poor girl couldn't keep this guy anymore, so I have a big sulcata tortoise.
Oh my gosh.
Yeah, he's 7.5 pounds. She brought him in, and I was like, oh my God, but people love tortoises, right? So I just wanted to show you.
Yeah, thank you.
Yeah. So
I'm happy to help out if I can, and probably even, point you to some of the other folks that I know in the area. One of the great things about the work that I've done is I have a pretty broad network of folks that I have worked with in different ways in the past. And, but yeah, happy to help with that. And, with this tortoise that you just noted, the pet trade is, there's a lot of great things about it in terms of the ways that it could educate people about critters. But especially when you're talking about like these turtles and iguanas and some of these animals that live very, very long lives. I think a lot of people don't realize when they when they purchase them, that they're going to have them, you know, beyond their kids' college, graduation, wedding, and, you know, and everything else. And so
Well, that's what I say to them. When I say to them, it's a 40-year commitment, because, you know, they're all talking, and then they're immediately that's a game changer. You know, once I say it's a 40-year commitment, the parents are like, okay, yeah, that's never happening. So once they get a little information on, you know, it's not a rat, 2 years, you have a wonderful life with it. You know what I mean? But 40 years. So yeah, we're trying to do that too. And, you know, the red air slider in the Northeast is, you know, through the roof. Every pond is filled with them. So, but it was really, everything you said was great and very, very inspiring. And it is just about that click when you're young. Anyway, I had the same thing where you're just like, okay, this is it.
Mhm.
And then it never changed. I was the same way. It just never changed. Some people it changes. They like that for a while, but I had the same thing. And I grew up in Brooklyn in an apartment building, you know, with none of that.
Mhm.
So
That's
yeah,
great.
I'll reach out to you because we really want to, you know, there's nothing like this here, and it's so important. And people, the other thing is people love turtles.
They do. That is
They
true.
do.
Yep.
So they're an easy sell, you know, to really educate people about how important they are.
Yep. So true.
Thanks.
Yeah.
I love that slide that showed the different podcasts and other ways that you're reaching out and sort of, you know, doing that advocacy on a larger scale to all these different audiences. And did just listen to the ologies. That's so much fun. I recommend it to everybody.
That's just pure silliness. There's no lessons in advocacy.
Oh,
in that.
I learned some things about toads.
Oh, good. I'm so, yeah, I do. It was a fun one. So I'm glad for
Yeah.
those of you who have seen it
Mhm.
or heard it, I should say.
Yeah. Well, thank you again for all the lessons. They were, they applied to, you know, your practice, but they were very widely applicable. So yeah, we
Yeah,
all
thank you.
use them. So,
Yeah,
appreciate
happy. I just noticed another question in the chat. I don't know if you want
Oh,
to,
good.
I don't want to extend
Yeah,
if you need to shorten.
No, go
I just
ahead.
saw this one about plants and the North American model, which is a great question. So native plants are a really difficult thing in terms of regulatory authority. And what I mean by that is, you know, laws and rules and all that kind of stuff. They have to be rooted in some sort of piece of legislation, whether it's state or federal or maybe even county level policy or something like that, that gives an agency the ability to set laws or regulations to manage a certain thing. So like I said, you know, amphibians and reptiles are technically considered wildlife, you know, broadly. There's a few exceptions in certain states in like a particular type of, whether it's amphibian or reptile or whatever, that they don't consider wildlife, or maybe they consider them game, or maybe they consider them bait in some states. But that was part of, you know, the whole conversation. And when it comes to plants, there's a lot of agencies, state fish and wildlife agencies, or state fish, wildlife, and parks agencies. There's a few of those around the country where they do consider plants as part of their management authority, but it varies from state to state. And so it really just depends on where you are. But even then, I don't know that they have the ability yet, or maybe at all. And maybe it does, maybe there are some in some states to regulate the collection of like native plants and things like that. I know there have been some federal efforts with like ginseng and, you know, a couple of other plants that have been, you know, highly in demand in the commercial trade, you know, similar kind of story, but on the plant side of the world and things like that, that they're trying to figure out some better broad scale regulations, but I don't know as much about that. Similarly with invasive species, invasive plants, invasive animals, what I found was that, you know, these agencies, when it comes to like invasive animals, you know, they have the authority to regulate for their native animals and manage for them, but they didn't always have any ability to place any controls on like the movement or the bringing in of invasive animals. And so A lot of different states were kind of trying to figure those things out for other purposes, and it also applies to some of the disease concerns. But anyway, so I guess the short story is that it varies quite a bit, and so you may just have to look at your local state Department of Agriculture or your state Fish and Wildlife Agency may be able to tell you more.
Great. One more question here. So it says, oftentimes advocacy can be quite exhausting to pursue. So how do you maintain momentum or reconnect with your why to continue
Wow.
self-motivating?
Yeah, that's such a great question. I think generally speaking, whatever the cause might be, I think for most of us that engage in this work, if it's important today, it's going to be important tomorrow. It's going to be important next year. It's going to be important in 5 years, and so maybe you have to think, okay, maybe right now, and a lot of times like some of the calculus that we undertake at NPCA is, okay, that the House of Representatives just shifted, so this strategy that we were using before, we're going to have to shift to a different strategy. So we have to regroup and we have to rethink. We have to get to know some people, see whether or not they're going to be amenable to having, conversations about these kinds of things. What are their views on this particular topic? What are their views on more generally like landscape conservation, or in our case, parks or wildlife or, things like that. And finding, those places of common ground. But it's an ongoing, strategy effort, to stay with the work. But I think, the biggest thing I can say is that if you feel like you're not getting anywhere, the best thing to do is just to regroup, reevaluate, maybe think about like, are there other partners that maybe you could work with that have had other successes, or are there, other voices that you could bring to the table that might be able to influence things more. But yeah, I think it's a perseverance,
Yeah. Great.
Right.
Excellent.
Well, thank you all. I really appreciate this opportunity. Great to be with all of you. I'm sorry I can't participate in the happy hour. I have to run to another meeting, unfortunately. But I really appreciate the time with all of you.
Thanks, everybody. Thanks for a great conference. See ya.